chat. Hello, hello, hello. Okay. Yeah. So last time we did a bunch of type checker stuff, which was really cool, and really interesting. Like the type checker is kind of like the executor, like it has scopes and everything, except it's way easier. Well, at least for these basic things, I guess. Like if we want more advanced things, then maybe we're gonna get into some hurdles. But for now, it just, yeah. I've been thinking also a little bit on how to get like auto completion working in the LSP, like using the type checker to help with that, like using the scope that it built up to help with that. But there's a couple of other things that we need to get in place before we can actually get to that. So like the parser kind of, right now if you have a parser error, it would just, you won't get any type checking either. So if you're in the middle of writing something, you're gonna get a parser error, and then you won't get, you won't get any help from the type checker either. So we have to fix that. Right now I have, and since last time also, I've been like I did a little bit offline and improved like the error messages from the type checker, and I added some type checking stuff. So right now, if the LSP is working, maybe it's not working anymore. Yeah, it's not working anymore. But wait, what if we did that? Would that work? No. Okay. Well, I did some testing, and I had it working at some point, but now it's broken again. So, but yeah, what I'm doing here is I'm basically creating I'm creating an interface with vtables, a vtabled interface for the document store. So basically, the document store is a place where you can store, or you can request source. Like you can request so if you have a path, you can get the source out from that path. If you have, yeah, and then we're also gonna add more things. So we're gonna do, we're also gonna have get AST, which will give you, let's see, this will be like AST, where is this front end? I think AST, this will give you maybe AST script. And actually, maybe I should change this interface to have this generic documents, maybe. That you like, you say like get document, I get the whole thing instead of, yeah, maybe. Now let's keep it like this. So you get the AST. This will bring out the AST from the store, which is connected to this path here, which you get the AST. So we're building up this this interface here. Let's see. And then I'll show you also here, if we go to the front end document store. Now this one before was called just document store. We had basically two different document stores. One for the kind of, the runic command line utility, or the actual like interpreter program. And then we also had one for the LST or LSP, I mean. And so okay, and then but the thing is that both the LSP and the front end needs to have a document store. The parser, I've changed the parser here so that now, before we had like a function that took, yeah, everything has changed. We had a function here that took a bunch of these were like function pointers, and this was the context, and then we store the context in here, wherever that, yeah, we store the context in the parser. So it's a bit more complicated before. Now we just have this document store, which is the interface to the document store. So it's much easier now to create this, and we don't need to have different types depending on the parser. And it's basically, we've extracted that functionality into the document store as a interface instead. So that is a lot more concise and how do you call it, like you know, the kind of scope that the document store has is like it's stored in here now, you know, feature wise, concept wise. So we don't need to have these the different, like we had like get source was a pointer to a function. Now we just call document store get source, and that's that. Or put AST and get AST and stuff. So we need put AST as well. But then also, if we go to front-end document store, which is one of the implementations of the document store. So now how this works is that you create a front-end document store, then you call this function on it to get the interface version of the document store. So this would return the vtable, and I need to actually change this to do document store vtable, because we need to have it stored somewhere. So I'll just I just make like a constant variable here, which will have all of the pointers inside, so that we can refer to this vtable whenever we need to restore. So it's always going to be the same. This is just a constant thing which keeps all the, you know, the interface actual implementation here. Yeah, so now I just need to implement all the different things. So let's go back to the interface here. So we have get AST. Now we need also put AST. And if you want me to explain like how interfaces work here, I can certainly do it. I've done it before. So this would be like AST. Well, let's just call this script, whatever. And that should be that's just a not a pointer, and we don't return anything from this function. There we go. It could be an error maybe though. So also one thing about this is that you do need to like create your own error here, because these functions, the return type has to be like, it has to be like fully resolved. So basically you can't, you know, we don't know if the underlying document store has other errors that, like, we don't know what kind of errors it can generate while getting the source. So it has to kind of transform the error into one of these errors. However, you could do something like this, like you can have any error here, but I don't know. I feel like this is probably better. It also kind of boils it down to, you know, a more easily understandable error maybe. Like this is basically akin to you didn't find a file in the file system or in whatever source you look for the file in, and this one is basically everything else right now. So okay, and then yeah, so that's just about the errors, error types there. And of course these guys do also have these things, and you need to have a script, and you don't return anything. And then we just call put AST on the vtable. There we go. Okay, so we have these utilities for getting the source and the ASTs. Now we probably are gonna also add a way to get the type the type scopes out, because yeah, that would be good to have. All right, so I already made this get source function. Now, in the case of a interface, when you implement an interface function in this sense, you have, with a vtable and stuff, you have to have like a pointer here, or this is the, I guess, the traditional way Zig has done it before with the allocators and stuff. So you take this pointer. Now this pointer is supposed to be the front-end document store, so you have to convert it into this pointer. So this is kind of like a void pointer in that sense, because it's supposed to be able to represent different kinds of types that we actually don't know in the interface. So we have to have this as a void pointer. And the good thing about that is that we can implement in any part of the program. That's also part of the reason why I have this as an interface like this, is because I have two different programs that need to use this interface, and they have their own implementations of the interface. So yeah, this is, you know, how you could do it. So you have this kind of void pointer here. In C terms, this isn't a void pointer. I mean, it is kind of like a void pointer. It's like it can point to anything basically. And then we just convert it here because we know it's supposed to be a front-end document store. And now we have the context here, or the document store, so we can use the usual request document function that will do the same thing basically, but it throws other errors. So we have to catch the error, look for like file not found, and we didn't find a thing. Otherwise we have, you know, the generic like read fail. Well, it's not read fail now, it's like get failed. There we go. But that would have been this would be actually, like, if you put anything else here, this is gonna be a compiler. I don't get it now because I have errors in other places, but yeah. Anyway, we need to do the other things. So we need to do get AST, is this get AST, and then put AST is put AST. So we don't have these yet, but basically they are gonna be basically the same as this one, which is gonna be like get AST. We will pointer cast, we will request a document. Oh yeah, sorry. We do this. We have to get the document and then return document. Why is this unknown? Oh yeah, wait. We have to return this switch. Yeah. So now it's basically, yeah, these errors. Well, actually, oh, I need to get rid of this try here because we have a catch, and then we return the error if there's an error, and then now this is a document here. So good. Yeah, and then this would be the source. There we go. Now I want to make a convenience function that basically does this part, because this part is going to get done over and over. So I will have a function that is like just get document, which uses the same anti-opaque just for convenience, and this would return the document as a pointer. And now we can just say return here. Okay, so now instead of doing all this, we can say get document, or yeah, get document pointer path, and there we go. Actually, we can just say dot source directly. No, we can't because we need to try. Well, you can wrap it in parentheses and try, but yeah, I don't know. This looks a little bit nicer, I think. Okay, so then here's the AST, and that's basically all you need to do here. This would be the script, and then we have put AST. We will also get an AST out. Let's call it script, And no, it doesn't need to be a pointer. This is a void. We get the document. We then set the AST to script. There we go. So we have these functions now are fully implemented in the front end. And I'm gonna basically copy this and put it on the LSP thing as well. I already started this, but yeah, so this is another then implementation of the thing. This is the LSP document store. This works a little bit differently. And so we have its own implementation. And then we also have this document store, like, you know, function that will return the interface of this particular thing. So then I will also show how to use that later when we actually use it in when we share the document store. So so we need get source equal to document store or LSP document store get source, and so on. There we go. But there is a slight difference here. This is not front-end document store. This is LSP document store. We don't have a function called request document. So I have to look at how this is implemented here. We have open or replace, which is looking like this. What we can do is go to the LSP parser to see how it was implemented. This is like how it was implemented before. So basically you can see here for get source, we are resolving a URI from the path, and then we free that, and we get a document by calling get with the URI. So first we need to resolve to the path, and then we need to call get on that, and then we can resolve, then we can return the text or document not found. So this is the old implementation. So we can basically copy this, go back to here, go to get source, no, this one, and we will, well, okay, we could maybe put it here, like, oops, where did it go? Yeah, this part is what's gonna be common here. So we'll create a URI, and we'll do free, wait, resolve URI does not exist. Oh, something went wrong with the copy there. So we get resolve URI, we free it, we will get the document like this. If it doesn't exist, we will return error source not found. I guess it could be called document not found or something like that instead. Yeah, it's probably better with like document not found. Also, it's probably better if we say document store dot error dot document not found. Let's call this document not found. No, document not found. Yeah. And then this we will catch, return something other error. So this would be like get failed for some reason, or yeah, get failed. There we go. And you don't return any errors, so that's good. Okay, so that is our get document function. Now we can, yeah, just we have to, this is called text instead. The AST is yeah, it's called AST, so that's exactly the same. Put AST should be the same as well. And we will get the document and AST equals to script, because this should be a pointer there. Yeah, so that's exactly the same. The only thing that changed was get document. Maybe we should just have get document as the interface. I don't know. This kind of leaves it open though, because you might have get source and AST in different places. Although get document would kind of compile, I guess, but this would make it so that if you have them in different places, then you don't need to get them both when you get the document. Right now, it's how it works, so it's stored together, but potentially you could have them in different places if you want. So it's more decoupled, I guess. Document, yeah, we'll return that. There we go. Okay, that is our document store. What's happening here? Oh yeah, I was beginning this journey when I realized, hey, the type checker also needs to do stuff with the documents and get the sources, because I want to log stuff out in the logger. However, when I started this, I was like, yeah, let's have the same as the parser, so we add this thing and this thing. But then I just realized, well, wait, why am I not just making an interface instead? This is getting too cumbersome. So now we don't need this to be a special type. This is just the struct. It's just the struct here. And we don't need you. There we go. And we don't have this, we have a document store instead. Also much nicer that we actually have the type as well. So let's actually just import this directly. And this would be a document store, except it doesn't even need to be a pointer anymore, because how interfaces work is basically they just consist of 2 pointers. Also this is like a constant pointer, so it's not even a thing. And then this is just a pointer. It's just a pointer. It's in itself, so you don't need a pointer to the document store. You can just copy it. This is, which is very nice. Okay, now we need to adapt the code that creates the parsers and stuff. So the parser here, this is actually not a thing anymore. So we will, the parser lives, where does that live? In AST? No. Where is the parser? Front end. Parser. Oh yeah, it's its own thing. Run script. It's a parser, or what? No. Yeah, parser. There we go. So now this parser is no longer a function. It's just a straight up struct. So yeah, awesome. Now we can refer to that instead. This do we need this actually? Yes, we do. Okay, so this is actually the front end document store. It's a specific. There we go. Alright, I forgot to change all these to front end document store. So basically, all of these cells still point to. Still talks about like the front. Oops, not that one, and not this one, not that one, not that one, not that one. The parser is also, yeah. These things we can just delete now. That was like the old interface, I guess you could say. There we go. And the parser is. That's just gonna be parser.parser. Yo, borrow checker. Welcome back. Hi, Metallics. Welcome back. How you guys doing? Right, now you will be runic. Actually, you know what? This is probably gonna be the implementation, LSP document store. Because we wanted to have the same lifetime there. Probably. Or we could create it from outside, I guess. No, okay, let's just runic document store. Ah, we're initializing it here. Okay, but then it needs to be LSP. There we go. Why is this even a thing? There we go. Okay. Same thing here, I think. Evaluator. You have a document store. I'm giving into the snake case. You will be this. Parser is parser. There we go. Makes a lot more sense now as well. Yeah, I really like that change actually. Hello, Mr. Shadow. Welcome. Document store. Okay, let's see. What is going on here? Okay, yeah. This error is different. So I just put this here so I can see what kind of errors we get. But I can just remove that. Expected type document store found from the. Oh yeah, so we're initializing the parser. So now here we need a document store interface. So what we do is we just call document store, and that will give us the interface. It's kind of like the. Yeah, it's kind of like the allocators. You know, you have to, if you initialize a GPA like this, and to get the allocator, you just call the allocator function, and then you get the interface. So it's the same idea there. Where I'm from Sweden. I'm creating a bash-like scripting language. Right now I'm working on. We were working on the type checker before. Now I'm working on like a little bit of the infrastructure around getting like source files and their ASTs and stuff and storing them. 2:40 p.m. Oh, okay. Yeah, I was wondering because if it was early or late or whatever, like what the time was. Source not found. Yeah, this is, yeah, now you see this error here. So now it's like, yeah, we don't have this error. You have to say document not found actually. So very good. Document not found. And to make this even better, we do document store error so that we can refer to the error properly. Okay. Use of undeclared. Parse import. Well, this could be runic document store. There we go. And now this is a front-end document store. To get the actual thing, we would get we would do this. It's kind of cool also. I think that this will actually work. So basically, this is not a pointer, right? However, it is mutable. And if you look at the signature here, this requires self to be a pointer to front-end document store. But this is not a pointer. But it's mutable, so it kind of becomes a pointer to wherever it's stored in the local scope here. So that's yeah, that's great. Oh, you're starting to learn C++? Cool. Why? No, just kidding. Why not Zig instead? It's much better, I promise. No, I'm just joking. I don't actually know. I haven't done C++ in like, I don't know, 15 years or something. But I do know that I'm not gonna stray from Zig for a while. How are you doing with C++? Is it your first language? No field arena instruct document store. Okay, let's see what's going on here. We're parsing the imports. Oh, we're trying to get the allocator off the store. Okay. Does it need to be that we're requesting the document? Was that how it worked before? Like we're requesting the document. Whoops. And the path that you would put in would, well, it's not even used, so it doesn't make sense to use the actual thing. Yeah. Okay, so this doesn't make sense. We could just as well do this. Wait, is this wrong? No, that's just a string. And then we just free that because it's being used anyway. And we get the document. Now we can say get. What do we actually want here? We want the script. So we can just say get AST now instead. And resolve module path. I don't think we even need to do this actually. It kind of depends. Oh, we do, because we have an importer and a module name, right? So the module name is like relative to the importer. So we still need to do some juggling around there. However, this would be the AST actually, or the script. And then here, yeah, we don't need to do all this crap. Oh, wait. No, we don't get the AST. We get the script like this. Oh, because the parser lives on the document, I see. Okay. Yeah, that is actually the case of both documents. So maybe we'll actually create another interface function that will create the AST, like parse AST, or parse the source. I guess just parse. That would just give us a path, and then we would just get, I guess we can get a parse error now also, parse failed. And this would be, yeah, AST script. So parse would probably put the AST as well. Right. So now we go to front-end document store. We need to implement this right now. Is Zig stable now? It was changing very quickly a few years ago when I tried it the first time. It's not exactly 100% stable. But it is, I guess it's more stable than it was before. I'm not sure how much more they're gonna like rip out and redo or something, but yeah, right now it's like the last major version did some changes that I had to spend like a day or two to fix in my project. They changed the reader-writer interfaces very drastically, or not that drastically, but a little bit. If you were using file readers and writers, now instead you are gonna use like the same interface, which is really nice. I like the changes, but yeah, you would have to watch out a little bit for major breaking changes. I'm speaking to the people in the other place. I'm speaking to the voices. I only know C++ for wanting to port tools to Mac OS. Huh. I mean, it's stable, it's stable in the sense that it produces programs very well. I haven't run into any compiler bugs that's like insane or anything. Backwards compatibility. Sig doesn't care about that, like C++, where you have dozens of functions do the same thing, but each function fixes previous. No, it doesn't care about backwards compatibility. I mean, why would it care about backwards when it's like a new language? It's better when it's a new language. It's not supposed to be. You have to kind of live with I mean, you're not supposed to, some people. Okay, I'm talking before I'm thinking before I'm talking, and I'm saying stuff. If you build a big project in Zig now, you have to account for that there will be major breaking changes that you would have to fix later on if you want to upgrade Zig to a later version. And there are actually major projects out there right now written in Zig. So yeah, but yeah, so I think it makes sense for Zig to actually don't care about backwards compatibility, because it's a new language, basically. And it's better to do it right first than to have a bunch of weird backwards compatibility things that will just confuse people and make the language worse, basically. That's how I feel, at least. So I think it's good that they do this. And it's up to the people who implement things. It's up to the people who use Zig to actually take that responsibility of, you know, dealing with the breaking changes. But one thing that I will say, it does have kind of like backwards compatibility with C, but that is just because it brings it enables a lot of stuff, and that's also just because it's so close to C that it has these special things just for C. But yeah, I think that's good as well. Although they could make it so maybe they can generalize it so you can have any language. I tried to get Mac Game Engine to work, but it was a dev branch and I couldn't get the version manager to work for that, so I stopped. Oh, okay. Yeah, it can be a little bit tricky, especially, I mean, the libraries that you use also have to be like the same version. So yeah. Yeah, and ZLS, like it works pretty well for 0.15, which I'm using right now. I don't like to use like the master branch and everything. I don't want to run into some weird compiler bugs that prevents me from doing things. Like Semver, it specifies OXY is not stable, and you need to account for that. Like that too, mistakes can be fixed and don't have to live forever. Right, yeah. Right, as long as they don't say like, hey, now it's stable and there's not gonna be super breaking changes, then it's probably good to start using. If you think about using it in like, I don't know, a serious project or something, that's gonna be like a big thing. But I mean, it's up to you as well. Just have to take the risks into account. Okay. Okay, let's see if we can fix this issue here. Missing, right, so we now need the parse thing. So we need to implement the parse function in the interface. I'm just gonna copy this parse. We don't have a script, and we'll, I guess, yeah, we'll return the script. So we'll get the document, we will call parse on the script, are we doing that somewhere else? Load document, parser, we're just initializing it. Yeah, we're just parsing it. I guess we could also just return the parser. I guess we could return the parser. Yeah, because the parser is like that. Yeah, let's just do that. Let's just return the parser. Parser, get parser. And then we don't have this error here. And now we have get parser. Just give us a parser. Actually, a pointer is probably better to have. There we go. Now back here, this is get parser, and we will get the parser out, and we just return the parser. So it can do whatever it wants with the thing. Oh yeah. Hang on. This, yeah, we need to do the address there. There we go. Okay, now you don't exist, so we can actually, yeah, we can just remove you. Yeah, just double checking. This parse file, not sure if this is even used here, but I guess we can do it anyway. Have it here until we figure it out. Okay. you are not the parser anymore. It's gonna be runic parser, parser. Okay, yes, now you are document store. There we go. Cool. What's happening here? All right, so get daisy. Actually, this is just we're gonna get the parser. And then we just do that, and this would be so module path. Okay, let's do one more thing. Let's get the actual document path, maybe, or can we? I don't know. It's kind of weird. Like, does this resolve module path? That should be an absolute, yeah, so that should just be an absolute path. We can use that just here. There we go. Z came out in 2016, so it's been nearly 9 years. What the hell is still not stable? So Rust took 9 years since the conception to be stable. We're gonna have GTA 6 before Zig becomes stable. I mean, yeah, I believe that. Yeah, I mean, I don't know. They did. I mean, Rust still runs on LLVM, right? Zig, they actually made their own backend. So that's that. There's that. And I don't know. I don't actually know what's planned. Like right now, it's on 0.15 is the latest stable version, or the latest, latest stable version. 0.16 is the next one. I don't know what's planned for 1.0. It just feels like, yeah, it's a long way away because they're like making progress to 0.16. So I'm not sure how many more steps will be for 1.0. I have no idea. But it's exciting because they could add more and more cool stuff. I don't know. Or, improve the standard library and stuff. I'm all for that. Do you know, guys, this new Zig backend produces optimized executables as LLVM? I don't know. I think LLVM is slightly faster from what I read. The first iteration I think they did on the backend there, like LLVM does like a slightly better optimization for some of the things, but the compiler for Zig is like, it's way faster now than the LLVM. Also, it has support for incremental compilation, but yeah, we'll see how good it will get, but. Yeah, they have definitely more control and they can improve things over time as well. Oh man, 2A. I always do this, like accidentally create a file called 2A. Okay. Now, right, we parse the script. We handle the error. We have the parser here. That's a pointer already, so we don't need to do that. There we go. That should be good. Type checker needs what? The document store. All right. Okay, here we go. There's a whole bunch of issues here now. And let's fix these first. Right, you need get parser. just getting the parser, except it's nullable. Not sure why I made it optional actually. I guess I made it optional because of like a safety issue, safety thing when we do this. I think it's safe to say that it should always be there. So I'm gonna unwrap it. If there's an error, we'll notice it, of course. Oh. Wait, how did I do this? Usually I have like if we have, so basically return if we have the parser, we get the parser out, then we need the pointer version. Otherwise, no, not no. Otherwise we have like unreachable, yeah. No, you are a parser. There we go. Get parser, get parser, get parser, get parser. Oh yeah, pointer. Documents. We need to get the interface. Now instead, you need wait. Okay, so we need a document store here. Workspace. All right, let's just add the workspace here, I guess. So we can grab the document store. How many use the zig-like? Well, I try to use it if I can. I'm not sure if I actually am using it. I don't think so, because it's like it still says LLVM somewhere. And yeah, SIMD works. I believe like the first iteration I did, SIMD worked for things. Wait, I think that's what that's what was missing. I think the SIMD stuff, like the vector types, which I used in my game engine. So it I couldn't use the new backend there. Also, I think it only works on Linux, if I'm not mistaken, or at least not on Windows. But yeah, they did improve in 0.15, but I don't remember all the details. You can go and read the release docs. Well, there are SIMD now, so I mean, yeah, you have to create like a vector type. I don't know if they have automatic SIMD for arrays. I don't think so. I'm not sure. But for vectors, there is like explicitly telling to the compiler that, hey, this is SIMD-able, and there you have like special operations that you can do on vectors. It does not support Neon ARM64. I don't know. I have no idea about that. What is your issue? Okay, pass the workspace. Change the order. Allocator usually always the first. Okay, why are you complaining? Parser, path, pointer, pointer, path, parser. Oh, there we go. There we go. Okay. Wait, one more thing. You don't need... Where's this coming from? It's there. Okay, cool. Request document. No. So what do we need here? Now we need to change this a little bit. We don't have a document anymore. What we need is the source. So I'm just gonna say get source. And this would be the source. There we go. Easy peasy. And of course the error now, we need to extend this error to have a document store error as well. There we go. Get cache document. So we don't really have this anymore. Well, okay, importer module name. We don't really get the document. Where are we using this? It's only used here. And what are we using? The AST only. So instead of doing this, we have to get the module path to solve. Like that. The name is import module name. Importer is import importer. And we want to get the AST. This is going to be self document store get AST with the module path. And yeah, it's not parsed, and then it could also be an error. So I will, yeah. Let's see. Is this the last thing? Evaluator. Command executor. Wait. No, evaluator. You need to be document store. That's the interface. And here we just need the source, so we can just say get source instead. Okay, now there's only errors left in the type checker. And it's kind of funny. I asked the AI to kind of add logging here, so it didn't understand how to get the documents, so it made like a source cache that we would keep around, but I removed that, and now we have the document store instead. So, and it's really nice. The AI is really nice for convenience like that. If you, yeah, just follow this pattern, and then it actually went ahead and added everything in, so I didn't have to do it manually, which was really nice. Although it did like copy all this logic here, but whatever. All right, piano coder, no problem, man. Focus on school. Focus on your scholarly duties. Okay. Well, you can. What is this path? Oh yeah, we don't have path. So basically, okay, instead of okay, the AI was like, yeah, you should like you have this is the entry point. So this is the entry path of the compilation, and or I mean whatever, and the but what I want to have is basically like a trace instead. So I'm just gonna remove this. And there we go, that fixed the problem. Get source. We can remove this entire thing. And instead we have document store get source. There we go. And you have a bunch of... Okay, so there's some kind of error here I think we need to add. Well, it's probably going to be the document error. So document store error. Okay, there we go. That's all the compiler errors. So now it should just work. If we close and then I open type checker test, it doesn't work. Okay, we will do runic type checker test. Okay, it says identifier not found. So this was the error that we got before. Now what I want to do is I want to log type checker. So here you can see everything that's happening here. We got an error bubbling here. We got literal hello. And then for some reason we get identifier not found. So I'm not sure if it missed a couple of places to put the logs, because that doesn't make sense to me, because it's a string. But it could be something else. That's the error as well. See you later. Okay, it's really nice to have the logging now. But let's see. Report expression error. Yes, yes, yes. Yeah, so these lines are basically added to every function, which will make it so that we can basically trace everything that's happening. I'll just BRB 1 second here, I'll be right back. All right. Yeah, it's pretty cool because these lines are very generic, so they can be basically put in any function and you don't have to change the code. It would be cool if you could kind of encapsulate this in some way, because you have to have like the defer has to be in this function, you know, and then you have to have the label, this one has to be in this function. The error has to be passed, but it would be cool if you could like try to encapsulate this. It's not really a huge deal. It's just 2 lines of code that you can copy everywhere. But it would be cool if we could, yeah, I don't know, maybe some kind of time thing or something. I don't know. Maybe you could have like a wrapper around the function. Let's see, which ones do not have run block in new scope? Why not? Binding declaration. Why do these not have it? Run function declaration. Like it just put it at some of the functions. I would rather have it like on all of the functions. Now this one is a little bit special because this is kind of like a main point area where here we log a little bit more. So we log out the tag name of the expression type, and we also log out the actual like the source code as well. No, I want these 3. There we go. Array. I mean, I guess it's like, you know, maybe you don't need every single function, but it's just nice to see where you can see a trace of what is happening and where things are going wrong. So for example, identifier didn't have anything, so it's probably something like happening in here, but then that didn't show up in the trace. Materialize binding type. Sure, why not? And here we have like validate type assignment. Here we have a bunch of different ones. I'm just gonna add it to everything here. Very nice that you can just copy paste here. So as you can see, I added a bunch of type validations now. Okay. Oh, some of these doesn't have self. Let's fix that. Okay. Identifier not found. Oh, okay.
This is, I think this is a compiler bug. If I change, like if I refer to this specific error in this specific error set, I get a compiler error here saying that it expected a union type, but it found this error set type, or this error type, error literal basically. If I remove the defer and say it disappears, the error is not there. If I introduce the defer with a capture, if I remove the capture, I don't think there's an error here, no. But if I capture it, now all of a sudden there's like an error here, which is kind of weird. But the way to fix it is basically you just change this to the keyword error, and now there's no issue anymore. So to me, the lowercase error and this is the same thing. That's the way like errors work in, like error types works in Zig, is that they are basically just a string, and the string gets like indexed into this whole error kind of database. But it's basically, this is a unique identifier for an error, for this error type. So if you have two error sets, so errors 1 is an error set that has like, this is the error, and then errors 2, and then, you know, this would be true, errors 2, yeah, so this is actually true here. This is the same as this, it's exactly the same, but it also is exactly the same as this. Yeah, this is also true. So it's just a name. It's just an identifier that is like, it's kind of like a global identifier almost, that gets automatically created here. And yeah, so I don't see a difference between referring to, you know, a specific error in a set or doing this. To me, that's the exact, almost exactly the same thing. It's just that I think that this is better, because then we can get like auto completion for the errors that are actually available in there. But to get around the error defer, we have to use the keyword error. I think that's a compiler bug. I haven't looked it up or anything. I should probably look that up or report it if there's, maybe it has been fixed in 0.16, or maybe it hasn't. Maybe there's an issue reported. I don't know. Okay, we have no more compilers again, so now we should have more logs. So let's test this again. Still get identifier not found, of course, but now we get more of where it's actually happening. So this is like the last expression that we, so this is like the expression that we're actually trying to do here. And then we run a string literal segment, and we get not found. So let's look, so now we know where the error happens. So let's look at run string literal. Now the string literal is can be interpolated, so that's why it's a little bit different here. We have a bunch of segments, and each segment could either be a string. Let's see. It can either be just text, that's just a string, or it can be an interpolation, which is an expression. That's basically it. And then each string literal is just a list of these. And then we run this on that. And if we go in here and we say if we have an interpolation, which we shouldn't have, we should only have text. We run the expression of the segment, right? But we shouldn't have a segment expression. Wait, we get the error here? Oh, there's an assignment. Okay, we do both of them. Okay, I understand now. So we do like both, because we're kind of like reporting the error. Wait, or are we? Hang on. Identifier not found. Where is that happening? Run identifier, identifier not found. That should just be an error that gets bubbled up. Yeah. So I'm not sure why it's continuing here. That's weird. Okay, there might be some wrong with the flushing. Let's do rider flush. No, we still get the same order. Okay.
It should like bail out here. I'm not sure why it's not doing that. This is like a try, so if this is an error, it should just... We're doing like try lookup, identifier not found. The defer catches the error. No, it doesn't catch the error. It like inspects the error and logs when there is an error. And then we also, but the catch here is for the log. The log can technically be an error. Okay, so then the error should bubble up. Oh, I see. We have run assignment. If this is an error, we catch it and we report the error. So why is that not? Okay, I see. So it is swallowed up. It is swallowed up. Okay. So we swallow this up with the yeah, we get we report an error here. We should actually we should add logs to these so we can actually see that actually. Yeah, let's do that. Let's just grab a log somewhere. And we do report. So we can see that we're calling these. All right. Now let's see. Yeah, so now we get identifier not found and we report this expression error. But then we also continue to do the thing. And this is a string. Now it's still the weird thing that is like we're running a literal segment and then materials binding type. Where does that come from? Because if we go through run expression, we should see run expression here and not. But I think what's happening is that we get text and it just returns the text. It just returns text. Maybe we should log the results here as well. And then you should be done with string literal. Assignment. Ah, so it's probably part of the assignments. We get the identifier, or we run the identifier, like we're validating the identifier, and we're validating this expression, which is the you know, or not initializer, but the expression of the assignment that you want to assign to, like the result of the assignment. And then we do materials binding type. Okay. And you report identifier not found. Right, okay. So this is how it works. Basically, this is a good example of how the type checking system works here that I've done.
So basically we have a bunch of run functions on expressions, on different kinds of expression. Now assignment is one expression. So we have this function called run assignment, just because I didn't know what a good name was for these functions, so they are prefixed with run and assignment. But basically it's type checking or semantic checking these expressions. So this will type check an assignment. And to help us, we have our type checker main struct, and we have the scope, which is the kind of the type scope or semantic scope that we're currently in. And in this case, I think we're just at the top scope of the thing. And then we have a bunch of, for each expression that we need to validate, it basically contains a bunch of parts. So we have like identifier, expression. The span doesn't, we don't need to check that, but we have identifier and expression. That's all we have in the assignment. So we have the identifier that we need to assign to, and the expression we need to assign it to. So what we do is, okay, if we are gonna assign a variable, of course it needs to exist in the scope first, according to the rules of the language. So then we have this run identifier, which will basically do that. It will check if the assignment exists, or I mean sorry, not the assignment, the identifier exists. If it doesn't, we will report an error. I just realized that we should probably put this in run assignment and not have it out here. But anyway, that's basically what it's doing. It's validating that the identifier is in the scope. Okay, it doesn't even check the type here. Now this one, it does like a generic check on the assignment expression itself, which you saw it went in checking it's a string literal. Okay, everything seems fine. If it had expressions inside, it would check those as well to check that everything looks good inside those expressions. But yeah, it basically checks all like semantically checks the expression. But what's also happening in an assignment is that since I'm supposed to have like type inference in the language. If we look at the source code, this is type checker. So here's the source code, and yeah, there we go. And you can see that, for example, here we have b equals, this is b, right? And B doesn't have a type notation, so at this declaration, at this point, we don't know what type B is, right? This is a declaration. However, we do have an initializer argument as well into this expression. This whole thing is an expression. So we take this expression, we declare the variable B as a mutable, and then we also assign the string type to it, because we have a string on this side, so we know it's a string, right? However, let's say for some reason, I'm not sure how this will happen in the language, but let's say for some reason you don't know the binding. But basically, if you go down here now, the only thing we have is like, this is a B identifier. What it refers to depends on the scope, right? So it depends on the scope. Now this scope is the closure of the function, so we should have access to this scope from the function. So it has access to B here, so we know that we're referring to this one. So when we do a lookup on B, we have to first look at this scope to see, okay, do we have because you could have potentially a variable declared over here, you know, because we allow shadowing, and so they can have the same name. But if it's not found in this scope, we will check the parent scope. So this outer scope is the parent scope, and this obviously has a B now. Also, it's also, you know, order dependent. So when we get here, we can't have the B declared down here. It has to be above this, because we haven't processed down here yet. So we process B, we say, okay, this is a string. When we get here, we look up B. Oh, it's a string, okay. We know it's a string, and this is not a string. But then I have a generic function that will actually try to assign this type to this identifier, which is this function here, materialize binding type. So this is a binding, also called we're binding B to something,
And in the type system, it's not bound to a value, it's bound to a type. So here it's bound to a string. Here we're trying to bind it to an integer or something, a number. So we need to check, like, can we do that? Can we bind b to an integer or whatever type we have on this side? And that is what this function is doing. So this function takes the identifier name and the type that we're trying to assign to it. Okay. So, and we also need the scope, of course. So we have the name, and then we have like maybe type expression, because that's kind of like the types, how they work right now. I'm not sure if it is gonna be a maybe here, but we'll see. But basically, maybe kind of means that it's kind of like we don't know what type it is yet. I'm not sure exactly how in the language this is gonna pan out, like, but most of the time now we do know what the type is, especially when we have the string literals like this, right? So, but I still want to support the kind of assignment to, you know, if we didn't know the type of b, and then you bind it to an expression, we should infer the type to be this, whatever this expression is, right? And then we know the type of b. And then if you assign it something else, then that's going to be a type error, because it's not the same type, or it's not, you can't assign that type to that type. Okay. So here we are looking at the type expression. We are trying to look up the name, which is the b. Now, or, well, was it b, or which, was it something else? Where was that? Okay, it's y, right? So y does not exist. It's not declared, and that's why it's declared in the scope here. So there's no issues here, but it's not declared in this scope. So this will be an error. So y doesn't exist. So that's why we get an error here when we try to look up the name. So we get an error thing here. And we return an error identifier not found, which is meant to be like, hey, yeah, this identifier is not found, of course. So maybe if the identifier is not found, maybe we should just skip this expression. We can run the expression, but we don't materialize the binding type. Yeah, because we don't have anything to check it against. So it doesn't make sense to materialize the binding type. If this was an error, so let's do this. Let's do like found identifier, or identifier. Yeah, just found identifier, fine. Is false or true. I guess we assume it's true, and if we get here, we will set this to false. This was not found. And down here we will check, like, if we didn't find it, we return here. But we still want to keep the processing going so we can catch all other errors. But we don't do this specific check, because we don't have a type to check against. Okay, let's see if that works now. So now we should just get the error, the type errors. There we go. Okay, so now if I do LSP restart, we should get a bunch of type errors here. There you go. Identifier y not declared, a not declared. And we can even do this, like we can try y equals, and then interpolation here, hello name, and now it should check the interpolation as well. No, it doesn't. Okay. Okay. Oh, maybe it's because it's running it as a pipeline. Like echo doesn't exist either, but that shouldn't be an error. Wait, did it crash?
No, doesn't look like it crashed. Not sure why it just stopped working. Okay, I guess we'll try and remove that. Okay, I'm not sure what's going on now. I'm gonna check if we ran into the same issue here. Yeah, okay, you can see here sometimes the Runic LSP goes up to like 100 CPU. I don't know why, but you can still kill it. And we restart it, and there we go. Now it works. So yeah, that's a bug I need to fix there. But yeah, the echo, so this pipeline is not checked, and that's why this also works, because technically this could be a pipeline. It could be an executable code name that we can execute. It isn't, but yeah, that's what is like a difference between the assignments. If I were to try to assign this to, you know, my name, now we should get the error. Or did it hang again? Yes. Okay, there we go. We get the error. So, yeah, cool. There's a bug with LSP right now, as you can see, that it doesn't really work. But this is yeah, we get this nice like errors now, so that's cool. Also, yeah, these like type assignments, yeah, it adheres to kind of the rules of the language. Now, I think I want to kind of generalize these rules, and then I need to be able to then use the type system. Yeah, I'm planning ahead a little bit here, but yeah, really cool. It works now. If you run the type checker, it will just report all the errors as well. So or I mean, this is just running the function, the program normally. You can to do like type check only, to do like a dry run basically. So if we do it on like scope refactoring, okay, we get another error there. Member object type undefined. Okay, yeah, I think imports doesn't work right now. Imports are broken again because the type system is like, it's a little bit more convoluted to actually create the imports. Maybe we should actually work on that to make it work again. I basically implemented almost everything. I mean, there's missing stuff as well, but yeah, here's like the members thing. So member access is what this is. And so we have the member access, and we're trying to evaluate the scope. And then apparently this doesn't have a type because it's an import expression. And the import expression doesn't have a resolve type implementation right now. Because yeah, I haven't like implemented this fully here. So it's not going to find a type, and then that results in a member access object type error, or type not found error. I'm just trying to think, okay, how could we implement this then? Because basically we need something else here. The scope is not enough now, because the scope is kind of like local to the module. we need some mechanism to be able to register a whole new module scope. So we actually need something, well, we need a current scope, but then we also need some kind of module interface where we can create new modules. Yeah, basically create modules or get cached modules. So really, we should maybe even just have the type checker here, the whole type checker. And then the type checker should have like a module system. So let's do like modules. Let's just do string array hash map. And let's make it unmanaged, sure. And this, what is this gonna be? It's just a bunch of scopes, I think. Pointers to scopes, or is this the actual scope place? Yeah, I guess. So when we do a type check, we create the scopes. We create the scope here. I'm thinking, maybe also, man. Maybe, okay, maybe actually the type doesn't really need that, because the type checking is gonna be, maybe we just need a module type instead. Actually, right now we just have, well, we don't even have a, well, we have the struct type, but that's really not enough anymore. I'm gonna add like a module type. And the reason is that I want to have the name of the module, like the path to the module. And then, because then you can you can cache it, like I guess that could be the only thing that's in the module, like in the type. It's just a name to where it goes. And then the type checker would have the responsibility of resolving that. But that it's kind of the it's not really the same pattern as we have like for these. No, it resolves into this module type, and then the type checker would have to resolve the module type into whatever we need, or it's gonna use the module. Yeah, okay. So the module type is gonna be here. So let's just do module type, and we just have the path to the module. We could just print this. We're like, I have this formatter set up for all these types. I don't remember why. For debugging, I think. Anyway, good to have. So it's just a path. And that's it. I think that's all we need right now. And then the type system would have to figure out how to get the scope from that. Where is... Oh yeah, the block. Whatever. Binding pattern. Wait, where did the thing go? Here. Let's go back. Let's make this a scope again. Let's just make a... what we need is we need the allocator and we need self, because we need to like resolve this module name. And we have like a bunch of different places where we have this function, so I guess we can use this function here. So we have the allocator, we have self importer and module name. Now we should have a module path. And we just put it in here, and the allocator is like an arena allocator, so we can just fire and forget here. So this would be a module path is module path, but it needs to be a pointer, so we actually need to create a new type expression, and we will populate it and return the pointer. There we go. Yeah, all these errors are like mixed with this now. So now let's go. Okay, cool. All right, now. I do still want to keep the module thing around here, because I do want to be able to store the scopes by modules. And then we need a bunch of utility functions here. Let's do below the logs, type check. Let's do get scope, get module scope. This is going to be a path. Actually, we could put... No, let's do path. It's way more generic. I was thinking of putting the module type in there, but nah. Okay, so what we get here, we get a scope pointer and possibly some kind of error. So let's do return modules get path. If we don't find it, we return a module not found. SIMD in Zig. Yes, it exists. It's built in into the compiler. Which is cool, because then we could even extend that to the runic language. I kind of want to use SIMD for matrix multiplication. Yeah, I don't know much about matrix multiplication, like those kind of things in computer science. Right, so modules equals empty
It's also like, I think like to me, like, you know, plus, minus, whatever, it makes sense. But then you have these bit manipulation stuff, and it's just like, okay. I mean, sure, you can like, how do you even reason about that? It's like you have to either you have to be so you have to do it so often that you're like very good at it. But it just feels like such a, I don't know, weird way of thinking about it. But you could optimize things into oblivion with that kind of stuff. I guess it makes sense for places where you actually do need optimization at that level to have that. Luckily, this language is not reliant on speed at all. It's like, it's just reliant on being like easy to use, but also have a little bit of like safety built in. It's not supposed to run quickly, just like Bash script. It's like, if you want a program that runs fast, you create a real program. This is just for like quick and dirty scripts. Switch must handle all possibilities. Right, so here we need to now, if we get a module type, we actually can try to run the member access on the module type. So let's do try run module member access, which will have the scope and the module. No, it doesn't need to be a pointer. Module access scope and the module, which is type expression module type. All right. So this responsibility of this function is basically to check that the access that we're trying to do on the module itself is good. Now this, what we're trying to access is always going to be an identifier, I guess, right now. So I will just, well, let's add the module there, and then the identifier there, maybe even a name. No, let's just use the identifier. Sure, why not? So this would be an identifier. It doesn't need to be a pointer, I think. No. All right. So basically, we want to check first, okay, do we have the module? If we don't have the module, we need to kind of parse it. So let's, so basically, okay, let's do some top down here. Let's do like this. Module scope equals self request module scope. So the responsibility of this function is to check if we have the module. If we don't, we will parse the entire module and return its result. So we get the scope out, right? And then we can validate the member access. So, but if it already exists, we just return the scope. So that's the responsibility of this function. And the module itself, I'm just gonna, yeah, let's just give it the module thing. We don't actually need to give it the scope. It doesn't need the scope. It doesn't need the identifier. We should get a module out there. Then we want to run, well, then we have the module scope. So then we just check if the identifier exists on the scope, I guess. So we will just, well, we can just run identifier using the module scope now, or with this identifier. I guess
it needs to be a, okay, whatever. Let's just make it into a pointer, I guess. And we'll do this. So we'll run the identifier, which will, I'm just gonna make it so that the run identifier automatically reports an error. Yeah, I want to do it like, I want it to automatically report this error here. But we don't know if the identifier is, okay. No, okay, yeah, let's do this. Let's do, if we didn't find it, we will not do that. We will report a span error instead. And the span is gonna be identifier span. There we go. And this would be the name of the identifier. Okay, now, oops, it should get, wait, span error. Right, the error is identifier not found. And we don't return it. However, we could return a bool, which denotes that we found it or not. So this would be false, and this would be true. So if we return true, we found it. If otherwise, because it's useful to know, because here, for example, we want to know if we found it, so we can store found identifier here. We don't need to do any of this anymore. And we can do try now. There we go. I mean, I guess we could run this first, and then we can just say if we didn't find it, we return. No, this is more explaining what's happening here, I think. You could also, we can also change this bool into an enum. Identifier, run identifier result is an enum, which could be found or not found. And then this returns the identifier result. If it was found, we return, well, if it was not found, we return not found. Otherwise, we return found. And then now we can say if found identifier was not found, we return. Or you can put it directly in the if, but it's such a long statement, so I'll put it in a different place. Okay. And then where is the identifier? So now we can do this, because we don't care at this point if we find it or not. Error uni is discarded. Oh yeah, let's do try there. Okay, one thing at a time. So basically what I want to do is result ij plus equals m1 ik times m2 kj. So are you in the world of just like ij, are you gonna iterate? Or yeah, I guess you could just do like a nested loop, 3 level of nested loop or something. Like, you know, whatever, ilang or m, wait, results length and then result. Now you could get the type out as well if you don't have the actual thing. No, actually you should be able to do this actually. Yeah. And then because you're accessing length, you're not accessing the content. Length should be, well, the content should be okay. Hang on, I've actually never done a multi-dimensional array in Zig. So let's say that this is like, I don't know, 10 by, or I don't know, 3 by 3 matrix equals undefined, right? So then you should have like length on here, and you should also be able to access like the first item and take the length from that without actually having to like initialize anything. And here's the J. And then I guess you would need M1 0 length for the K. No, wait, you're switching K. So does the, so the matrices has to be the same. It has to be 3, like the. It can't be like 3 by 5. It has to have the same length in both things that you in your example there. So it's like length A, length B is that. So we're assuming they have the same length. We're going through length. Well, okay, if they have the same length, then it's going to be, you know, just matrix length 3, like this. Okay, then you can just do this, I guess, and then result I J equals matrix 1 IK times matrix 2 KJ. Was that what you needed? Am I thinking about this correct? Hello, Penguin. Wait, did you leave for sports yet? No, you were in school. Or something. Or was that someone else? I don't know. Anyway. Boom. No field name module. And then also, like, if you do this, I'm not sure how to do this in vectors. Like, you could have, you know, instead of this being arrays, it would be a vector m length of m64s. But this would be, actually, no, it would be this guy here equal to undefined. So now we have vectors instead. And instead of doing this, maybe we could do something else. I'm not sure actually. Because here you're... Maybe you could do something like... Because I think you can do something like this with the like the SIMD in like the SIMD operations on the CPU. Like you kind of change the order of the indices with some kind of mapping. But I I don't know. You could read up about that. I'm not sure how to do it in Zig. But this is how you would, I guess, make the nested thing there. But you could maybe also store them in one array as well. I'm not sure. Anyway, let's try and make this work here. Oh, it's module type. I see. I guess we can call it module. Right, this would be more like, well, what kind of errors do we have here? We have like, well, okay, I guess if this goes wrong, let's return null. Let's just do that. Okay, and then that will generate an error anyway, so. I mean, okay, let's do that, and we'll also log. No, then we can actually handle we can actually handle this error in, because it will return null, so that would make sense in when we're trying to resolve the type. So we handle it in the type checker, yeah. Okay. And here we're running the identifier. Yes. Wait, no, we don't. Or wait, why are we just running the identifier? So basically, this is basically just checking if the member exists on this scope. It doesn't make sense. This doesn't make sense at all. I'll just remove that. Right. Okay, yeah, I guess we don't need the scope. That makes sense, actually. No film. Right, so we don't have this function yet, so let's create that up at the module stuff here. So let's have request module scope, and let's get a module in here. That would be type expression module type, and we will get a scope out. Or an error. Okay. So I guess we'll get the module from get module scope. What? Oh. Cached module, or no, this is the scope. The cached scope is equal to this. I guess we could just return it. Return this. We're gonna catch the error and we're gonna switch on it, and then we're gonna say if this is an error module not found, then we will like load the yeah, we will load the module. We will basically, I mean, yeah, we will basically like type check that. We need to change this to take a path. Where do you actually get your information from? Self AST, right. Okay, that actually doesn't make sense anymore. We don't actually store AST here. What we would do is when we type check, we get a path that we want to check. And we put the path here. And now we also need the document store. I think we have the document store actually. And here we like get the AST. So this would be the script. So we're trying to get the AST with this path. If we cannot do that, we catch and switch on the error. And we're gonna check if this is document not found. If it's document not found, we will just say, okay, so then, no, no, this should never happen actually at this point. We should have the AST here because the parsing happens before, yeah. So we should actually have this available. If it's an error, I think we just try here. Yeah, this is just try. So we get the script because we're assuming we have it, and now we can use the script here instead. No, this is a point, I think. No, it's not. Okay. So here, if we didn't find a module, now we can say self scopes from AST, and this will be module path. If we got anything else, we just return that error. So that should give us the scope there. We don't have an AST. We don't do this. There we go. And you don't do that. It is mutated because we're gonna put it here. No, we need the path actually. Resolve path. Okay, now you can be a const again. Script get AST. If it wasn't found, we return document not parsed. Okay, you can be module not found. Oh, get pointer, right? Get pointer. Not sure why that didn't work, but okay. Self scopes from the right. You would be a try then, I guess. Oh, you return. Okay. Right. So, also, okay. The scope. Okay, so now we also need to publish the scope as well. So we get the scope. I think we'll do it in this function actually. Yes. So I will do self modules put, because at this point when this is called, it has to be a new thing. So I'll just use the arena there. The path will be the key, which we need to, well, now do we need to dupe it? Let's just dupe it just in case. And then the value is scope. But that, no, it's gonna be scope in it. Okay. Do we get anything back? No, we don't. So now we should get the scope back out. Get pointer path, and we can unwrap it because we know it should exist. Okay. And now we actually return a pointer and not a not pointer. And we run it. And you are a block. Yeah. Yo, Blue, do you need heap allocation in order to use SIMD? I don't think so. I don't think so, no. Why do you ask? I mean, I guess usually when you want to do SIMD, you probably want to do it on large amounts of data. So if you can't fit it in on the stack, you have to use the heap, I guess. So maybe, you know, maybe that but if you just, yeah, if you do it on like well, technically SIMD is actually, well, I mean, technically SIMD is operated on in the registers. So you first, it's just a matter of like getting the data into those registers, which you can do from anywhere, I guess. I don't actually know, but yeah, I would assume you could. Okay, so now this one, the scopes, because SIMD has like special registers, as far as I understand. Like they have registers that can contain larger amounts of data, like 512 bits or whatever at the time, or something like that. Like there's different variants as well, and like older processors don't have the newest features and everything, but yeah, yeah, I'm not too well versed into that, but there, yeah, you should be able to have it on anywhere you want. Expected type, blah, 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 found, blah, blah, blah. But why do you ask, by the way, Blue? Out of memory, yeah. We're duping the path, yes. Error union is ignored. And also the thing there. You must handle all things. So what is the thing you don't handle? Oh, the module, right? It's over here, I think. Validate module type. Validate type assignment module. Which really shouldn't happen, I don't think. Well, I don't know. So this would be, yeah, the module and then assignment type. All right, Penguin. Module. And then we get the module and assign. All right, assignee. It's always the thing. Okay, so what do we do here? I guess they have to be the same. So basically, we'll get the type. Like we'll switch on assignment type. If it's a module, we get the module, and then we'll just do a. I guess they have to be the same path or something like that. I don't know. We'll do like if equal assignee path and then module path. If they are the same, well, if they're not the same, we will do report span error, not report assignment error, that's right. Assignment error, assignment type dot span, expected is assignee, actual is assignment type. There we go. Otherwise, it's also going to be an assignment error. So actually, we could just have assignment error here, fall through. If this is true, we just return. That was the issue. There we go. I was thinking about big data, that how I will store in before in the instruction. Right. Yeah, I'm not that well versed in the actual like assembly instructions, but it depends then on what language you're using. Like if you're using C or C++ or whatever, I think they have like intrinsics you can use. Or are you using Zig? Then you can use vectors. Which language or are you thinking about? So basically, if I show you just a simple example, like let's say I have a vector A, which is of type vector, and let's say we have like, I don't know, you can have like 512 items of U64s, for example. And then this is undefined. Now this is on the stack now, so that's on the stack. I'm not sure if it will fit here, but let's do that. And then what you do is you just do like a plus b. A plus b, you get a new vector. And this is vectorized. This is like, this is SIMD now. So A is added to B in a SIMD environment, if you have support for it on the processor that you're compiling to. Is there a way to convert Zig code into AS assembly? Check out Compiler Explorer might have that. I'm not sure if there's like a flag in Zig which will get you the assembly code. You can also try to use like a disassembler. Compiler Explorer. I'm gonna see, do we have Zig here? Yeah, we do. So check out this page. And change is an amazing site that all programmers should know about. No, but it's really cool if you want to see a compilation of different programming languages compiled into assembly, to check out what they are doing. Well, it does, and also it doesn't. They are building their own backend, so they are moving from LLVM. But yeah, like right now, you can. I'm not sure if the Compiler Explorer does output, like goes through the LLVM pipeline. But you can check out, like, you change the language to Zig, and on the left side, on the right side, then you will see the assembly result on that site that I posted there. I guess I can show you here in the thing here. So we have a Zig here, and here's the assembly code. And then you can also like see, okay, this part, what does this part, which part is which? It maps the code here. Okay, so you did know about this website. Okay, cool. Yeah, I think when I encountered this first, I think they didn't have Zig, but now they do, apparently. And you can even choose the version here, 0.2. Compilation failed. I've never used 0.2. Okay, anyway. Just trying it. So, and then you could do something like this to get the Zig version change anything. I mean, yeah, I guess it changes how, yeah, what features are available and what they compile into, I guess. But then you could use this code for vectorization. Just look up like vectors in Zig. Alright, so we need a span on module. There we go. And you need a span now. So this would be self.span. Type checker. Right, you don't want as AST, but you want well, I guess we'll do this. Yeah, I had this safety measure here, but we need to move this down here now, because yeah, it failed, it crashed and burned otherwise here. You need now, wait, where's the ASC coming from? Oh, it's just self.path. Yeah. And then we need to switch on this error now, because it could be like document not parsed. If it's not parsed, we just return, because then we don't need to, yeah, we don't want to return like any errors there. If there's something else, we will log and return as well. Yeah. Oh, that's it, I guess. Wait, that doesn't feel like I did everything. I hate it when you get that feeling like you did a bunch of changes and it feels like you still have work left to do. But then all of a sudden there's no compilation errors left. So now you have to go back and find where things went wrong. Okay, this one's, I think, very much should work. Module, where's the things? Import expression. See? We need to do this now. Yes. So let's see. I don't think we need the scope. We do need this. All right. So we have the module name and the importer. Now we're gonna try and do resolve type. So this would be the module type. Resolve the type. Arena allocator. The scope. Okay, I guess we have to forward the scope. Okay, so we get this. If this fails, like if this is null, that should be like some kind of, that we didn't find the module. So I guess we would return like error module not found or something. I mean, I guess we could return module not found. We could also just report the error. We don't need to have an actual error in here. We just report the error. Report span error. Span is going to be import span. Error is going to be module not found. Severity is of course an error. Format module not found. I wonder if I should produce the path. We could also module. Let's do like module s not found. Yeah, it would show the file name as well. So we don't even need to. This would be the module name. Yeah, there we go. And then we don't return module not found. We will do try. Oops. Here, and then just return nothing. We abort this whole thing. Okay, but if we're here, we should have the module type now. There we go. Now we have a type expression, and yeah, and the type expression, of course, is a module type, and then we just assume it's a module type at this point, and then we have the path. So now we have the path for the module, which should be the fully resolved path, I think, or is it? Yes, it is. It's the fully resolved path, so we can use that. And then we'll do return request module scope. Oh. No, not return. Actually, what the? Yeah, we get the type. I guess we don't actually need to parse it if we don't use anything from it. Really? Unless we just... No, we do need to parse it actually, because it can run code. That's right. So I guess we'll just try to get the scope. Or we can also... No. Request from scope. Yeah, this is the one you want to use if you want to get the cached value. So we get the... So this would be the module type. Dot module. Right. How do you get the path? Just module path. Yeah. So we get this module scope. But then we don't really do anything with that. I think we don't care about the scope at this point. We just want to request it so it gets type checked basically. And so now we have it in our module system. Okay, I think that's it for the run import expression. Use of undeclared identifier error. Oh yeah, dot error, that's right. There we go. Okay, so now the import should generate, like, we should like request the module scope, which in turn will also like run type checker with this, you know, run everything with that scope and everything. So, and then put it in our cache. And whenever we need it later, we can just request the cache to get the module. But this will be the starting point of putting the module in. So the module will be type checked and everything. And then if we have a member access somewhere for module here, module member access. There we go. So we get the scope, request scope, and we run identifier on the scope. There we go. And then later, if we, for example, we want to implement the pub keyword here. We want to kind of know if the identifier can be found on the scope, if it's like public, because this is like an outside access. So if it's not public, it shouldn't be available. But right now you can access any kind of identifier on the top scope of the module. Okay, let's see if this works now actually. I'm gonna do this. Of course, this turns a bunch of errors. Let's see, what kind of module do we have? We have this module. So let's try and import the module. Okay, now we have the module. And the auto completion doesn't really work, but let's say we try to do this. Okay, I saw the LSP crashed, so let me kill this. Wait, where is it? Let's do LSP start. Okay, maybe it's like... Actually, okay, let's run the type checker on this file now. Oh, we get some kind of crash. Okay, that explains things. I'm not against leaving out public-private scope. Right, I understand. I don't know, it feels like you can organize your stuff better if you can determine, like, so you don't like get cluttered with a bunch of stuff. I guess technically if you want to have private stuff, you could put it in another module that you import, and then it's like, well, it's not really private, but I guess it's more out of reach. It's not really out of reach, but it's further away. I don't know. It's just, I don't know. I have a little bit of annoyance when it comes to, like, you get all these weird variables that you don't really care about. You just want the functions, for example, or something like that. Prefix with underscore to make it private. Well, I think I would rather have a public modifier in that case, because that's the same thing, except it's just a different syntax. I like to have access to inner workings, right? Yeah, I like that as well. I'm on the fence a little bit. I don't actually know. Okay, we'll see what happens. I do like it in Zig when you have access, like the all structs, there are no private variables. The only way to get like private things, I think, is like if you have the declarations, but I'm not sure if declarations work across struct instances. Like each struct instance doesn't have its own version of, I'm not sure if they are static is what I'm trying to say, like the declaration on a struct, or if they are per instance. I think they're static. But I do like it when you can access all the fields. That is really cool. Because it's like, yeah, you have access to all the fields, but you also have the functions. So if you want to use it in the quote-unquote correct way, you can use the functions, or look how they are, you can inspect how they are created and stuff. But then you can also potentially, you just use the items or the fields themselves to get all the data you need, which is really cool. But for this language, I don't know actually. I'm not sure. I think the purpose of the modules is going to be to expose a bunch of functions, basically. And not so much, well, and types as well. But I don't think the types are going to have maybe a concept of public-private, like the structs. I'm not sure, actually. But depends on how big the library is, but I like the idea of just having a single entry point exposed to high-level methods. Actually, that's a good point. Like, probably maybe the libraries in this is not going to be like that huge, but it's because it's just a scripting language. So you're not even, it's not even meant to be this sophisticated sort of. It has all these, you know, you can make like huge libraries and stuff. It's supposed to just be, you do quick and dirty scripts that you have use for at the moment. Basically, that's what it's supposed to be. It's not supposed to be this sophisticated language with all these different libraries and stuff. So maybe it's not that, maybe it's not super important to have the public keyword actually. It's a good point. Zig depends on a file name. Uppercase, it's an instance. I think all files in Zig are structs. You can define fields directly in any file. And all the function declarations are, it's like a hidden struct in all files. Which I think is a nice way of like organizing and talking about the files themselves, like the modules themselves. They are just struct types, which is really cool. Because it really, you don't need a separate module type. You just have a struct type. But it's also kind of weird that the files themselves are struct. I don't like the idea of putting fields directly at the top level. I always create a struct so that you can see what the name is and everything. No, the casing doesn't matter. You can have like types with lower letters. It doesn't matter. I think I'm gonna force all, like, if you have a type, it should be capital, uppercase in the start, variables and everything else, or functions are small. And the imports are gonna work a little bit differently. Also, like imports in Runic, I've gone through this a bunch of times, but it's not fully sort of thought out yet. Because they act as functions more than structures. They are kind of like functions and structs merged together. Because when you import, it will actually run the file as well. And all the functions, of course, are gonna be available here, so you're gonna be able to like call them, but it's also running the entire file as a function as well. So kind of like Zig's files are structs, Runic's files are functions with like declarations on them. That gets which kind of implies also that if you have a function and you have a let's say you have like a local variable here, greeting hello. Now you can actually say, potentially, you know, if we do this distinction, you can actually say like hello.greeting to get that declaration. That's kind of weird, but it does that implies that you could do something like this. Yeah, the arguments are gonna be defined in like normal programming languages. They're gonna be defined in here, so you have like 1, 2, or whatever. Oh, come on, the LSP is crashing on me, I think. And then these two would probably, they will also be available in the direct scope of the function, so they would also be, you would also be able to like check these, and they are constant, so you could actually check, okay, what is this? No, this doesn't work. It has to be a function call. Wait, this doesn't make sense. No, that doesn't make sense. What would this be? This is just a parameter. But this would kind of work, but you have to run the function first, I guess. No, this won't work. I'm just kidding. This is super weird, actually. Yeah, I have to think about this a little bit, because you could think about this as being some kind of Runic file with arguments, and it takes, you can even put like standard in, and then everything here should be available, but you have to run the function to get kind of the result out, the scope out, and then you can, so this would be like Runic file results equal to Runic file. So this is kind of the same as importing, and then you can access greeting. Yeah, there we go. Functions are not side effect free. They will not be side effect free. Functions will, that they can do whatever. They can call executables, you know. That's yeah. You could have an extra argument passed through where you could add variables to. Wait, how do you mean?
Extra argument passed through where you could add variables to. So okay, so let me explain here. So basically this is argument position 1 and this is position 2. So here, like, to, okay, I didn't use this. So this would be like, let's say this is 1 and then this is 2. So this will correspond to, it's just like calling an executable with args. So this is 1 and then this is 2, right? And then if you require standard in, well, now it's like, well, it's a string. Maybe it's an optional, so you don't require it, you know, but you can require it, I guess, if you want. So basically, yeah, we're gonna have typed pipes like that, but I guess we don't care about that right now. Let's just do void. Void on standard in, void on standard out. It doesn't, which means basically you don't have side effects into standard out. You could have side effects that touches like the file system or does some other stuff, but it won't output any data from this function. But you can access this, so you don't have, like, you know, you don't have this anymore, you know, 1 or whatever you have, 2 is 2. That's not what's happening. It's like, yeah, we define it as normal program languages here, like this, and they are also typed as well. So and then we can, and then, because what's happening with the import is kind of the same as just running the function. It's like, yeah, we're loading in the function, the runic file as a function, and then we're running it as a function, and the result is stored in here. And then you can access whatever declarations were stored in this function, or in, yeah. So that would imply, as I said here also, that if you have a function that you just have like this is kind of like a local runic file in that case. And if you run the thing, you would be able to access the declarations in here. Yeah, that's the implication that we're working with, I guess. I'll just move this. I'll put this in a runic as functions. I already kind of have, okay, let's do like some ideas floating around how to do this. Okay, anyway, why do we get a core dump here? Panic, a search, total capacity, put, get or put, declare. Okay, type checker 324. Oops. They will be copied or cloned. Well, the constant will be a constant, so that won't. That will be, you know, that will be that. But I guess it could be a constant to a reference, you know, all that usual things. We don't have references yet, and I haven't worked out everything there. But so yeah, I guess it's kind of up in the air for now how exactly things are gonna work there. Let me just restart this so I get rid of all the things. All right, and let's do this. So this was type checker, right? 324. Run binding pattern. All right, let's enable the logs.
Okay, file not found. Interesting. Run expression. Okay, we get a module not found error. If this goes wrong, we return this, right? And this one is like, yeah, okay, we're unwrapping the module from the path. But what if the path in this is wrong? We don't find it here. And then we return this. If we didn't find it after... No, we should have a scope. Yeah, we have a scope. But this fails. Right, it fails to get the document. And then the entire thing is aborted. We get an error here, which should be something like document not found. And these are just tried. So I think here we'll do a catch. And switch again. Now this is the other error. And here it's like document not found. And this is gonna be, yeah, and here we actually do, now we do like try self report span error. No. Module span error is, yeah, just module not found. Severity error. Module not found, which is module dot path. Switch on standard possibilities. Right. So if we have something else, then we actually have some kind of weird. We have some other weird error, I guess. Yeah, it feels like files as functions is kind of like, and well, I'm not used to that concept. Like I know that, for example, Python works like that, because you import a Python, it will actually execute all the statements in the file. But it's not really, you can give it arguments or anything like that, like in this. Like in Runic, I will actually treat files as actual functions. And they can have arguments, they can have typed standard in, standard out, and give you a, yeah, it gives you like, kind of like a scope, or kind of like a process result thing out. And it will also have a lot of common with then executables, because executables is kind of like they are gonna be functions basically. They're gonna be functions that has string as standard in, string as standard out. I guess they are like optional as well, maybe optional strings. I'm not sure actually. And then the arguments are always gonna be like variadic string arguments basically. And the execode and they all could produce some kind of byte as an error. How would you define arguments at file level? So my idea would be, well, first I was thinking something like this, but then I was like, no, let's do well, let's do a third one. So basically I want to have something like this. You say function, and here's standard in, let's say it's a string, and then the function name, which I would just say at, and then we have, so at would denote like, yeah, it's this file, and then you would have, so this expression has to be like at the top of the file or something like that, at the top scope at least. And then you would have like the arguments, so you can have like, you know, argument 1 doesn't have to be called 1, by the way. Argument 2, whatever, and then the output could be a string or whatever. And this would be the expression of defining the signature of this file. So this would be at the top, and now you have access to these parameters, so you don't no longer have to kind of rely on doing this and then, you know, trying to parse it or whatever. You're gonna get a string or an int. But the thing is, like, when you call this within a runic execution context, you would supply this. You would have to supply this as a like these types. But if you call it like from the command line, I'm not exactly sure how we're gonna deal with that yet, because that's gonna be the same thing. We're gonna get a bunch of strings here instead of like these types. So if you have like maybe we can have a shorthand for like function main or something, and that will denote that the signature is actually gonna be you know, this will be the same as saying, yeah, we have a string, maybe string in, we have a variadic amount of functions that are strings, and then we have maybe out, and like a byte error exit code, something like this. Yeah, it will be raw standard in. Basically, actually, this could be. No, let's do an optional, because if you have a string set as standard in, maybe we'll force it to maybe we will force those functions to actually have to accept a standard in. Otherwise, they don't work. Like, they assume that they need a standard in. If you have optional, it's like, yeah, you could put a standard in, you could not. It depends on what you want to do, like the execution of the program or something like that. So this would be the same signature as all the executables. Executables should have this kind of signature. And yeah, so this could be like the shorthand for this, for example. So if you have like the main function, which is kind of the entry point of the program, you would maybe be able to do something like this, or this, or something, I don't know, or maybe this. So you don't have to type this out. Or it could also be inferred. Like, if you don't have anything in the file, this could be the type that's inferred. We could also have like, maybe the signature is like inferred from the usage of standard in, standard out as well. But I'm not sure about that. Not sure how to think about this, but if you also want to be able to run individual files, both as import and as executable. Yeah, you would be able to, but the thing is, then the signature is like, okay, but all of a sudden, if you have like an int here, or some other structure, like an array or whatever, how do you pass that into the program? That would be the next issue. Maybe we could have a standard, you know, parser for that or something that will, you know, take a string, try to coerce a string into the types. or something like that. It would have to be able to handle both. Yes, exactly. Yeah, it's very interesting. It feels like a cool thing. I've never really like thought about these kinds of things actually, like in programming before. All right, let's see if we can fix this issue here. Okay, so if this was not found, we report an error. Something else goes wrong. What do we do? Do we just report an error or do we abort? I think we just abort here for now. Well, okay, so if we didn't find the scope, I guess this would be a question mark. Yeah, I mean, I guess that's what we need to do. And now we should get a bunch of issues. Right, so if we didn't find the thing, I guess we just return, because if the error is reported in here, so then this doesn't really matter. Okay. No, we still get some issues. Yeah, there are some weird memory issues you can see here, like file not found, okay, document not found, report span error, and so we consume that with the span error, and then we continue, but then here in the binding pattern, something goes horribly wrong. Scope, I do declare what is happening? The binding pattern. Get or put out to the bindings. I see. Okay, let's check. Go back to the start. Let's do type check. Interesting, like this function never got any utility. I think that when I did a top-down programming here, I did this thing, but then I think this one and this one doesn't actually do anything. This was the only thing we needed. This type check inner. It just checks if we have diagnostics, and then we return this as an error. So it basically just compiles the result into, yeah, it compiles the result into an error or into a result. So this is not really type checking anything. This should be like a compiled result or something. And this one doesn't do anything. So I'll just remove this for now, and if we need it, we're gonna go back to it. That's the funny thing about doing those kinds of top programming, when you don't actually know like a lot of the details and you try to do top. Usually the first plan is like, yeah, that's not the correct one, but you kind of go through some of the kind of steps you need to take in order to actually complete, like do the program. But then you actually go down, when you do the detailed work, that's where you actually find out what you need to do. Collect diagnostics. Yes, but we are also creating, like, the main purpose of this function is to get a result out. So I like compile result better, because if we have diagnostics, we return an error, otherwise we return a success. Compile is kind of weird in this sense because we're making a language, but yeah, whatever, it doesn't matter that much. Okay, so I wanted to check. We get the scope out. I'm gonna call it scope and not scopes. And we put it in here. We don't actually need it in here, so I will just remove it from here. And we don't actually need the scope at all, so let's just do that. Now this will just run this type checker on the scopes while doing the thing. And what I was trying to figure out was if we mess something up with the pointers. This one tries to get the pointer out of the modules, and here we're putting scope in it, which should be put at a place that could accommodate the scope, and then when we get the thing out here, we should get the pointer to that scope. So there should not be any issues there. There could be something wrong with this path that we get in. There's some weird stuff here, like lock, pointer stability lock. State is unlocked. Bindings. I mean, it's very simple what's happening here. I mean, yeah, I had so much trouble with these arenas, man. Maybe it's the arena that, I mean, I might be using it wrong, but it's like if you use an arena together with, no, it has to be able to understand the size of what you have and if you can reallocate and stuff like that. It should be able to work with array lists. I'm not gonna go in and check a bunch of stuff. I think the arena works like it has pages basically, so when you allocate something that doesn't fit in the current page, you just create a new page and starts from there. I'm not sure if that's the issue though. Yeah, it's on the heap. resolve type with the thing. Okay, so resolve type calls that on what? Run binding declaration is this one. I guess it's when we're binding the module, maybe. But then you can see here, there's something super weird going on with the memory. So maybe something is, you know, something is messed up somewhere. I don't know the semantic of Sig arenas. So the Sig arena is basically, it's like this. First, it allocates some kind of page. So let's say you have a page like this, and then you can allocate things in there. So let's say we allocate you know, some kind of memory in there, and then the next one we allocate here, and so on. And then if you allocate something really big that just fits in, then it creates like a new page. This is the next page here, and it fits it in here, like something like this. But the thing is, like, when you, let's say you free this one, I'm gonna let's do A, this is B, and this is C. Let's say you free B, then there's like a gap here, and you can never get this back unless you free C. Then you would like go back, but if you allocate something new here, it's just gonna do it's gonna make a new page if this doesn't fit here, and it's gonna continue over here. So that means that it's not really good for like long-running processes that keeps an arena around. Like, it's not good for long life cycles where the order of allocating and freeing is not like synced. But it is good for just one-shot objects that you just need to allocate, and then you can just free up the whole thing. Because eventually, you will run out of error because it fills up all the pages. If you free up something, you don't get it back. Yeah, I think it's like if you free the last thing that you freed or that you allocated, and it happened to be the only thing on that page, it will release that page and then go back to the previous page or something like that. So you can potentially get back all the way to the start and then reuse the arena. But you can also reset the arena. So that is also, an arena is also good at if you have something that is like very short life cycle, but happens over and over again. That works also, because for example, in my game, I have a frame allocator which allocates a bunch of stuff in the frame, like in a game loop frame. So then it's just allocate, fire, and forget, and then after each frame, it just releases everything that it has allocated, and then you can start over. But the crucial thing there also is that you don't have to reallocate what you like, the capacity of the arena that you've already allocated. So you don't have to like get the capacity back. You have the capacity, but now you have all that places free. Yeah. Arena is probably good here because it's not gonna be. It's just gonna be a one-shot thing, and then I release everything. Hello SQF, how's it going? Welcome. Set up telescope diagnostics with grep and it shows previews of the errors. Oh, okay, cool. You should also note that, like, well, okay, the like NeoVim has like built-in diagnostics stuff, but I'm not sure if what I'm using, this one, is actually like built in. If I add some error here, I have this error list. I think this is, maybe this is actually telescope. Yeah, this is telescope. I think this is telescope actually. But basically this is like the built-in, I think this is a built-in thing in telescope. Yeah, there's a workspace diagnostics, and then you can just you can change how it renders the view. So you can do, if I have, this is my telescope kind of search. You can search for any kind of telescope picker, which is, you know, the source of what you want to look at. Here's for diagnostics, and then you can get it from here. Or I have mapped it to a leader EL. I will get all the diagnostics in this window, in this view, which is also telescope, but you just change the parameter slightly to get this view instead. Yeah, I think it uses NVIM diagnostics under hood, yes. I am using telescope. I am using telescope for a lot of things, like find files, live grep. Also, what's kind of cool is that you can, let's say you want to find .rn, and then you want to put them in, you want to like keep all the results. You can press Control Q to get it in the quick fix list, and now you have all these links that you can go through and do things with if you want. So that, I think that's kind of cool. It's really convenient sometimes. Yeah, send me the picture. Right. Let me restart. All right. Snacks. Is that like a telescope alternative? Pretty much the same pricker. Okay. Well, I haven't touched my NeoVim config like those basic things since I basically created it at point. So yeah. Sometimes I add a little bit thing here and there, but oh, the lazy creator. Okay. Cool. I kind of learned also how to interface with telescopes, so you can create your own like telescope pickers and stuff. Actually, do I have some of those? Easy Pick was like a plugin, I think. Current buffer, yeah, like the buffer picker, grep buffer. So I made this. You like grepping in the buffer, but then you get it in like a, you know, a telescope picker to do whatever you want with it. Oh, but that didn't work. Okay. Okay, so I basically never used that, but I implemented it and I'm proud of it now. But yeah, yeah, it's pretty cool. You get all these kind of built-in stuff. Tree sitter, whoops. Tree sitter. These are the different. These are like the scopes and stuff. Okay, cool. Yeah, symbols. Oh, that didn't work. Okay.
spells suggest smart open, health. Okay, some of these are broken right now, but I guess that's it. File types, fine. I sometimes I go into here to see, okay, what kind of commands do we have, and or if you want to see like mappings, key maps. This is very convenient to search for all the key maps. If you like this one, diagnostic, go to next. That's how I find that's what I'm pressing all the time after I save the file. Looking up dot files and a picker for looking up Odin standard library. Oh, okay. Still in the process of moving over to NeoVim LSP. Okay, so did you use Vim before? Or what? Or moving over from what? Oh, or do you mean the LSP config plugin? Because yeah, I need to do that as well. At some point, I still have NeoVim 10, so I need to update that as well at some point. But whatever. Okay, so why do we still get this issue? I don't know. Document not found. I was trying to figure out, because the only thing, like the main thing we changed was like where the scopes are stored. So that was what I look at, is like, okay, where is the scope stored? And do we ever mess with that? Like this returns like a pointer to a thing. This one gets it from there. Is it at any point where we forget to populate it? We catch module not found. We try to produce it here. Okay, so it's like when we try to do this thing. Because we should have already like parsed the module or type checked the module. And now we're getting module not found because the thing didn't exist. So let's check the path here. Wait, what? Oh, I see. There we go. Okay, that's weird also, but okay. There we go. Okay. So the path seems correct. Right, LSP config, yeah. Okay, you sent me the pic. Right. What is this? Python, okay. Okay. Oh, I see. grep preview. I see. The grep preview. But you should be able to just see the preview. There's like a setting in Telescope where you just see the preview, right? You don't have to do much. You just have to set a config thing.
No, well, okay, maybe. I should, but I didn't have that problem before, so I think I've used this file a whole bunch of times before, so it shouldn't have changed anything. We just need to read it. And something is going wrong with the path here. This is like a huge clue here. File not found. You know, obviously something goes wrong here. Is better? Okay. Yeah. Okay, so why is this happening? Module not found. Well, it is there. So that is strange. So what happens then? Module not found, and we return a error, right? We catch it. We return error or null. So I don't understand where the memory issue comes from. But maybe it's something else. Maybe it's the module type. Let's go to AST. Module type. Hang on. No, resolve type on, what is it? Import module path Is something wrong with this? What happened? Oh, thank you for the follow, humanoidism. Hello, hello. UI Wizard here. UI Wizard. The UI Wizard. God damn it, I lost it. I was gonna say the quote from what the hell? Lord of the Rings. The UI Wizard arrives exactly when you mean to. Okay, well, I don't see UI Wizard. I see dalloc and SQF. Well, you're not SQF, so you have to be dalloc. Yeah. Yeah, no problem. Okay, so if something goes wrong here, we have like this thing. This is like a derivation, or this is just a slice of the importer, so we don't need to like deallocate or anything. This one joins, and then we free it as well, so it shouldn't actually. No, yeah, we join it. So this should be a new thing, and then we just return this. So I don't see why this would be an issue.
Yeah, it's creating a new real path alloc will allocate a new string. I mean, I guess it could be that one. That's weird, like a pointer to import expression. I guess it could be that. That's the expression. If we go to the parser, it shouldn't be anything wrong with that. Yeah, we're allocating the importer path. We should probably like dupe these. The parser needs to live, though. Like it needs to live, but it should be. And self.path should be. Where does that come from? I think it's set here. It's set to whatever we call parse script with. We should really dupe that. All right. What else can go wrong here? Import. Okay, so this one is duped. The module name payload. Parsing a string. This is always going to be a new thing. Yeah, I think. Yeah, we even copy to arena here. String literal without interps. So everything is like there's no interpolation going on. We just append a bunch of slices to an array list, which is deallocated here, but we're copying it to the arena. And that's just a string. Yeah, this is just like a dynamic string basically, which we are appending all these to, and then we copy it to the arena. So it shouldn't be an issue. Yeah, so now, well, the only thing we did was basically we duped this. And this should already be in the arena. Oh, yo, SQF, welcome. The YouTube, yeah. The chat is very delayed. It's better on Twitch. You get like instant almost. Well, I have to look at chat as well. Okay, so right. Well, did that do anything? No, of course not. Where was the trace? Import expression. Right, so these two, like this is the path and this is the module name. They should be like available at this point. As long as the parser is alive at this point, these should be as well. It's kind of relying on the fact that we have those. Also, they are pointers themselves, so even if this is like a copied version, these should still be valid.
And this produces a new thing. Yeah. I am befuddled. Oh yeah, so humanoidism. What are you using? Like C? I didn't see there. Or what language are you using? Such a weird error, like locked. It's unlocked. It's not unlocked, it's locked apparently. And we don't have multi-threading, so I don't know, man. Oh, Odin, right. Sometimes Zig, sometimes Rust, sometimes... Okay. Yeah. I should try Odin sometime. Because it's like, it's very much like C and Zig. Except Zig is... Zig feels like the one, like the outlier in like trying to do new things, I guess. Much like Go and See, with a really good core library. Okay. Like I installed it one time and then I couldn't get it to work too well with the editor, but yeah, I didn't try too hard. Okay. Man, I am stumped here. I am very stumped. But okay, let's see if we can figure this out. So we're trying to do a pipeline expression where it says file not found for some reason. Document not found. The pipeline. I'll say, okay, so first it says like module not found, right? On this one. What about further up? Like it should run. So it just skips this one. Let's go. Where's like run statement? Right, so run statement, I think I also want to have the this trace here. So the statement, actually this yeah, I think I want to have it on these two, but not on this one, but whatever. Let's just put it here. Actually, you know what? We can check here. If statement is not equal to, I think it automatically derefs. We'll see though. If it's not equal to expression, it will do this. And this would be the statement now instead. And you would be statement. So actually this would be statement now. Oh man. Statement.
is just going to be log type check span, I guess. Span. And then we need source. Try so I go so far doing that doesn't even matter if it's HTML. I do backend. Ah, okay. HTML. Okay, but what do you do on backend? Python? It's a bit of a workaround. The way to do it is use OLS, Odin LSP. Okay. And then install tree-sitter syntax. Okay, well that doesn't sound too hard actually. Python with fast API. Okay, I never heard of that. Well, I've never done like a Python backend, to be honest. But it actually does sound kind of tempting with the whole. I do want to try out the HTMX thing with Python and whatever they were using. Like there was like a demo I saw. I think maybe they used like Django or I have no idea. I've never used that. What's your opinion on that? Because with HTMX, it's like at some point you get to the problem of reusability of like components and stuff. You never did that, to be honest. Okay. And like how you compose things, and yeah, I don't know. There's just something about having components like that which is really nice to have in like React and stuff. Incompatible types. Yeah, so we need to deref, and you should take a statement, and you don't exist. So let's create you. And source, and that. There we go. Long-time user of React, so I'm biased to that, yeah. I understand. I used back in the day. My first job, I think, was Angular 1. And that was not nice, if I say so myself. The idea of HTMX, but it's still, I like the idea of HTMX, but still limiting for large applications. Right, but I saw like a really nice demo where they showed like a working, you know, example, or it was an example. They rebuilt their UI in HTMX and like Django or something like that. And that it just looked very, very impressive. So it would be cool if you could get like the source code or something for that. See how they like organize things, because it just feels like you can do things in so many different ways. What's going on? Okay, so we have our log thing. Now we're logging the statements as well. So let's see. Well, let's build first. And I want to basically scroll all the way up and see. Right, now we see this here, so we're doing that. Okay, that seems to have gone well, I guess. And then we're doing this, and we're doing like identifier module, and we're trying to get the scope, and it fails because the module was not found apparently. Which means we just skip that whole expression, I guess. And then, or do we actually? What's happening here? We're running a statement. Which statement are we running? It doesn't show. Oh, it's an expression, so it's gonna show. No, there's file not found. Actually, let's actually show this anyway for expressions as well, because I am curious of what is happening here. If they're able to reach components with little friction, that is awesome. Like you might be able to do something like it because it always feels like you have to hack something together, because there's no, like, the idea of SGMX is like, yeah, it's gonna be super, it's like so simple, but then you don't have those kinds of utilities where you can like compose things. It's just like copy pasting a block of HTML string into other strings. Like that's what you feel like when you're doing. And sometimes it works really great, and sometimes you wish you had more utilities to do what you want. And I've never really been able to kind of, I mean, that's probably my fault, of course, but I've never been able to like build something that I feel like, hey, this could work, like I could scale this, you know. It doesn't feel scalable to me, but I might be doing it totally wrong. So it just feels like there's so many ways that you can get into trouble. With it, but yeah, because you don't have like checks and stuff. I guess potentially you could have like a test suite or something, I don't know. Where I work, we build a calendar with lots of interactions, so that's why I'm a bit more skeptical. HMS use case, right? Yeah, and I tested out, what's it called, the Alpine. Yeah, and you know, it's kind of the same feeling. It's like, it's nice, it works, but it's also like it doesn't feel scalable, because you're basically working with strings all the time, and you don't have any like LSP integration or anything. It's like you're just back to the dark ages, it feels like. So it's nice for, like, you know, small pages maybe, but yeah. Hook into the browser APIs for greater performance. Exactly. So that's like, yeah, we're reinventing Ajax again. Oh, hey, did you know you can just get a JSON and then you just get this different JSON or GraphQL or whatever, and you can build a thing on the client depending on what you need. It feels like we're running in loops, like the whole like web dev stuff is like we're going back and forth all the time. I guess potentially the thing that Next.js is doing with like SSR and that is kind of like merging the two worlds together, merging like client like hydrating and all that stuff. Like you're merging the two worlds together there, like the client render stuff and server render stuff. Does more than replacing an element based on request. Yeah. Oh, you don't need your purely client side. Okay, cool. Yeah. It's just for optimization as well. It's like, yeah, do we have this whole thing, but it's just when it gets down to it, it's only optimization. It's not really, you know, anything breathtaking really. but there's so much infrastructure around that stuff, and you have to kind of also adapt to it as a developer in like companies nowadays that use that stuff, because you have to think about things in a different way. It just complicates things. Okay, can we try to do this now? So I have run statement. Okay, this runs this. Okay, member expression identifier get module scope fails. Module not found. Okay, that's reported out. Apparently this is not found even after we imported it here. Does this make sense? Yes, it does make sense. Okay. And then we run the statement. Why are we not seeing this here now? Okay, there we go. Now we're... No, why are we not seeing this one? Oh, because of this. File not found. Also, when we do this, it should also like run the type checker on the import. But I don't see any logs there. So okay, we're binding the thing, and then it just quits and runs the next one. Did a lot of work for SSR early on, but couldn't find use case with clients I couldn't hold up with design or APIs careful for UI, so already good. Okay, so you're kind of you're doing like the SPA thing. Client only, like. Oh, you sent something? Okay. Editor with tabs in Vim or NeoVim. Okay. All right, cool. Yeah, NVim tree. I used to use. No, wait. I used. I think I used like Nerd tree or something like that. But now I don't use like a file explorer anymore, like a plugin. I'm using like the built-in thing. Yeah, that looks cool. What is there? The tabs. Yeah, that looks cool. Did you make that yourself? Oh, nice. Actually, we have like do you have tabs here? No, we don't have tabs. We should have like a picker for tabs. No, kind of. It's buffers, I think. Buffers. Okay. Well, it's not really the same thing. It's like a because the tab, like I can make a new tab with tab new, and this will kind of create yeah, a new tab. And then but buffers
so now I have 2 tabs. I have tab 1, tab 2, or whatever. But this would not show that really. I was thinking like, yeah, this should be, because it's like a very basic built-in thing. There's also like windows, but maybe it doesn't make sense. I don't know. I guess you could do like this. You have 2 tabs. Panes. Well, I'm using the like Vim terminology. If I click here, it's gonna change the tab because my tab bar is messed up. I don't really care about the tab bar, to be honest. I just use, you know, to switch tabs, I use GT. That will go to the next tab. I rarely have multiple tabs, and I always try to like have one file open at a time. I try to like optimize my workflow to be able to just quickly find where I'm going, and then I can go back and forth with Control O, Control I, you know, find it, like quickly finding things through telescope. Oh, you just have tab. Okay. Can I? No. But GT, I'm used to that now, and it's not. GT is like real close to each other as well, so it's not really a huge issue. I think it's the original mapping thing. I also try to look back into like original, you know, Vim features or Vim things, because there's so much there that I have no idea about, that you can just try to use like the built-in things a little bit more, instead of like, you know, oh, I wish I could do this, maybe there's a plugin. Oh, but maybe there's already a built-in way in Vim that you could already use, and then also kind of like, you know, use it together with other Vim commands and stuff. Can we solve this thing? All right, so the binding declaration. So hang on. So this runs without issues. Like I guess it finds the thing, but why are we not seeing then the type checking of the import? Is my question. And why are we not? We're not running on this expression here. We're running the binding thing, but we're never running this expression. So maybe that's the issue actually. Maybe that's the issue. So run import, no, binding declaration. Oh, I see. We're only running the pattern. We never run the, no wait, binding pattern on the type expression. But this is just resolve type. We should also run it on the expression. So this is the initializer expression. We need to run that initializer expression as well. Let's do that first actually. Let's do run expression. So this is the whole problem, I think. We never did this. We'd have to run this expression, because this expression is the import expression which will populate the module. Now it makes a lot more sense. Okay, we still get an issue. Let's see. We import. So now you can see, now it goes through here. And we're running. I'm so annoyed that it doesn't go all the way to the double quote there. I have a question. Why put A after W? Just so I save everything. If I change something somewhere else, it's just a tick that I have. I type colon WA all the time. I don't know why really, but I guess it's just a habit.
It's probably bad because if you accidentally change something in some other file, which usually it doesn't really happen, but then you just save that without really knowing, and then you have a bunch of weird changes. But fortunately, we have Git as well, so you would actually pick up on that as well. Hopefully. Okay, so that runs the expression, and then we get this, and then it fails because it's apparently it doesn't find this module. Okay, so let's look at why it's not finding the module, and then okay, so I guess, wait, it doesn't find, okay, yeah, no, we don't find it. This makes sense because we have not registered the module yet, so this makes actually sense. But then we go down here and it's like, hey, I can't find this file. Okay, well, that makes sense, but why is it like this? So now we have more of what's happening. We run the block, we run the statement, a binding declaration. For some reason, this binding declaration has like a weird path. So let's go and look at that. Wait, binding declaration, debug file not found. Where is this coming from? Document not found. Yeah, we're import. And we're trying to get it, and then we try to. Yeah, I guess we're running the module, maybe. This fails, so then we go in here, right? And we run this, or we get the AST, and then we run the block. Yeah. So I think when we do this, we should kind of show. Yeah, we should have like the defer here as well. And then I would like to show also that a little bit of this. Well, I want to show the path actually. No, that's the error. So here we go. Let's show the path. There we go. So now we should see that we are actually trying to run the imported thing. There we go. Now we're running this, right? And we have it, because yeah, we have the AST, we're running the block, we're running the statement. So something is weird with the result, I guess, of this module. In the AST, maybe, yeah, the path of this parser is like messed up. There's something wrong with the parser on the document. Or the AST at least. Wasn't it parsed?
Type checker. Type check. We're parsing imports here. Did this stop working or something? Yeah, we're going through. Right, we're creating an. This is like the expression walker. It goes through all expressions and parse, and then when we found an import expression, we parse that script as well. And then we recursively also parse imports on that script as well. Okay. And this parser be a pointer, yes. Oh, this module path is put in here, but now we actually, okay, I see what's maybe going on. No, maybe not actually. Get source path. Yeah, this file gets actually deallocated. Let's just dupe it straight here. Dupe path. Oops. All right. So there was something weird with that. Okay. Maybe. Yeah, because we're freeing it here. So. Okay. Okay. There we go. Now we can actually get to the module itself. You can see here, like, okay, we're importing this, running this, it goes through, runs this. So now we are able to actually get this thing. Okay, cool. Yeah, and then we're running through this thing here. And S should be like a not found error or something. Yeah. Identifier span error. Then we are back. No, we should show what is the actual file as well. It's kind of confusing here. Log check span. Yeah, let's log the line or the file as well. So file name, line, column, thing. File, line, column. Maybe we don't need the line because and the column because they are, you know, they're shown. Okay. Okay, there we go. Wait. Wait, why isn't it showing it? Oh, it's showing it only for the things. Okay. I want to show it here as well. Oh, that's gonna be... No, okay, that's gonna be so many changes. I'm not gonna do that right now. Okay, yeah. Span error. Now we're back. No, we're not. We're still in module RN, so it's like calling its own function. Okay. We're doing echo. Pipeline, run command, command part, string, literal, segment, binding pattern. What binding pattern? Okay, so maybe now we're back. Man, okay. Let's see. Log. See? I want these. I guess I could change all these to kind of where you also have like the span, the file name as well. There's just so many of these. Let's do like log with source file name or something like that. And then we need to somehow get this, like the log with short span or something. And we need to get the span. Yeah, except not here. Type check. We don't have a span. You have a span. Well, actually, okay. This does have a file name, so I will add that as well. You also have a file name. Check trace. Wait, what about this? Okay, apparently we have two different ways. Sure, let's extend this by adding a span. And we log the label. Actually, I want to log the file name first. There we go. Now we just need to add this everywhere. Block span. Now this is bad because this is not the same anymore for everything. Unless we create a span This one we don't really need it. I'll put a null there. Whatever, let's just put it there. Wait, was that it? Okay, now we want to replace these with that. So I just need to check that we don't do it anywhere we shouldn't. No, okay, not these ones. Okay. I mean, okay, actually, you know what? Yes, let's do it here as well. There we go. Now we just need to check all the, we need to fix all the spans. And we have the span here. Look. This is pattern span. Could probably make a macro this as well, but like wait, you don't have span? Wait, what is this? Oh, the stage. Oh, it doesn't work for these. Oh. Wait, it should. Oh, no, it doesn't. Okay. I didn't make it work on these. So we should search for that. And then W. There we go. Go back. Oh, you should have a function actually. Span switch self. Oops, this is a function, not a constant. Too much TypeScript. And then inline else the thing span.
Okay, cool. You have a span, you have a span, and you... Actually, you have... If we're an expression, we have to call span. There we go. Or, so now you should exist there. Cool. Oh no. Wait, why did that not work? This should work now. Why does this not work? I'm so annoyed. No, of course it doesn't work. I think it's the control. I'm using Control O, Control I, or Control O to get back. I think that's what's not working. Probably. It's like, okay, so if you change the line, you have to do more Control O's. Perhaps. Maybe that's the issue. Also, this one we don't actually have. We don't have a span. So you should just be log. There we go. Wait. Binding assignment. So let's do assignment. These are all assignments. No, this is shouldn't change. That's why you don't change the pattern, because it's so much easier to like change when everything is the same. Oh, you don't have anything. Okay, there we go. Let's see where we are now. Okay, now we can see which file we're like looking at. And so you can see that now we're in module looking at these things. When the things go wrong, we go back to type checker. So this was hard to see before. We go back now to type checker to run this, and then it fails. For some reason, I still don't understand why it fails, but now we have a little bit better debugging tools. I'm just gonna refill my coffee. I'll be right back.
Okay, so yeah, so I still don't understand why we get this error, but there's something going on with in here now. When the module has been complete, and then we try to run something in the binding pattern, for some reason the string array hash map is freaking out. When we do this get or put here. Maybe there's something with the name. Like if it's the same as a key or something, I don't know. Because it's like it's saying that else state is like not unlocked. Maybe we should just go in there and check what's going on. Alright, let's go to scope and get or put. I just want to see what the logic is, and that might give us some clues. I just wanted to look at this one more time here. The name of the declare. Is just gonna be that, which is either coming from like the type checker or arena or the parser arena. It gets put in here, and then we're kind of thinking that, okay, well, this pointer is gonna have the same life cycle as this scope, so it doesn't really matter if we store it in the arena or not. We can just store the key here. I guess, yeah, I think the key is like it's yeah, it's just copied in there. Because yeah, the string array hash map doesn't like clone, it doesn't duplicate the key or anything like that. It puts a new thing with undefined. Wait. No, that's if it found existing. Yeah. It puts undefined. If it's not found, we populate it here. So here's where we're populating it. Do we need to populate the key as well? Or what? No. If it didn't find existing, we take the key that we put in there. Yeah. So it should use the key we provided. No. I was thinking maybe we forgot to push a scope, but that's not exact. That's not how we. That doesn't work here. Coffee in the terminal, full dopamine cycle. Yeah. Oh my god, there's no space between the functions. I can't read this. No, just kidding. Get or put. Okay, what's the stack trace here? We are on 70787. Right, so we call this. I think, yeah. and then 889. It's the first thing that happens. We're locking. We're asserting that the state is unlocked. It just feels like something is weird. Something is going on with the initialization of this. So let's go back to scope. And we'll double check what's happening. Do we even set this? We set it to empty, right? Is there something weird with the unmanaged version of the string array hash map? We set it to empty. I don't know. Maybe if we change it to allocating, maybe it works better. But then we need an allocator here. Right, and now we don't need allocator here anymore. Fine. I was thinking I should save a little bit of memory by removing the allocator. Okay, I have no confidence that this will do anything. No. What is happening? Yeah, it's just the first thing happens, it checks some lock. The state is unlocked. When is it set to locked? When we lock, of course. Well, why is it like... Oh. Lock. Okay, did we deinitialize it or something? Undefined. And that, of course, will change the lock in that case. No, we actually never deinitialize. Actually, okay, wait. Hang on. 1 second. We put the scope. We put a new scope in here. We never actually go in and deinitialize this scope. I don't think. Especially when this is running. What is going on? Okay. It's saying like type checker test. Maybe we should include the lines. Run binding pattern. It has to be, you know, the. No, let's include the lines as well. Yeah. Log trace something. There we go. We have the span, so we can easily add the lines. So line and column, fine. Line and column. All right, line 3, column 7. Of course, it's crashing. Line 3. So it's still on here. It's still okay. So when it tries to bind this to this, it fails. Run binding pattern. It fails here. Oops. Okay, I never tried this. Like I think you can say like dot name or something like that, or just name, and it will kind of take the name, or not the name, but identifier. Wait, now it should be over here. Right. Invalid format. Dot name. Where is that? Print. User type. You can leave out separators. Argument. The numeric index or the field name of the argument that should be inserted. Score. You're required. So when using a field name, required to close. Okay. I just wanted to try this out. Right. So you actually have to. I think this is when, if you make something like this. Okay. I thought that you could. Well, actually, okay. You can, if we just pass identifier, this should work, right? What was it? Argument and then specifier. How do you separate them? Oh yeah, we don't have. Okay. So then S for string. Unused argument. Okay, whatever. I just wanted to try that out. Alright, no, not that. It's name. Identifier name is module. Okay, so that's good. But still, I still don't know what's going on here. Like, the only thing I could think about is maybe, like, there's something weird going on with the arena, so that it kind of overwrites maybe something in this with something else. Like, I've had issues with like that before, especially if you use like nested arenas. So I don't know if that's the issue. I'm gonna go back to this so we don't have to store the allocator in here. Let's say empty. Yeah, this function is not even called because everything is initialized with the arena. So yeah, if it was called, we should have gotten compilers here. No, we need the allocator. Hang on. Wait. No. I was thinking that maybe there's something weird with the parents. But that should create a whole new scope thing. It's like, okay, maybe it could be that this list gets invalidated. So all pointers that we currently have for scopes get invalidated because when we append this, okay, let's change the scopes to be pointers instead. And maybe even, no, not these ones, but the scopes should be pointers, because I believe, yeah, they, okay, yeah. Yes. So then I want to do that here as well in the modules. Just because when they get invalidated, these pointers never get invalidated basically. But this list gets invalidated, but now they don't get invalidated there. Okay, so now we need to create the scope again. Create a scope. Fill it with init. Now we don't need to supply the arena. That's the scope. And we don't even need to grab it again. First we need to try. And what's going on here? Instead of get pointer, now we just get this. Right, so now we need to create a new child. And the child has to be in it with parent. And then we return this. Actually, now we can just say get last. There we go. Right, now you need allocator. Okay, we need allocator again. Boom! That was the issue. Oh my god. These memory stuff, man, sometimes it can be a bit tricky. Okay. And I never seem to learn that lesson. The stupid array list when they invalidate the pointers. Yeah. Man, I don't want to have to get like keep all that in my head to like, yeah, you have to be careful with these things. I don't know. But I mean, okay. So basically, what was wrong was we store the scopes in a list. If we don't have, but I didn't have a pointer here. So these, the address of these, were basically the address of the underlying array. But what if the capacity runs out? You add a bunch of scopes, the capacity runs out. It has to like reallocate to another place, potentially, where there's more space. So now you have more capacity, but all the pointers inside, or all the pointers that are out in the wild, they get invalidated now because it's like a, yeah, it's invalidated. So yeah, we change it to a pointer. Now this is a stable pointer instead of an unstable pointer. And I think what was happening is basically when we were doing the type checking, we basically passed this, where is it? the scope around this scope here. Now we create it here, so it's always a stable thing. But before we put it here, we got the thing out from the modules and then passed it into here. And then this just run amok with this one pointer that eventually gets invalidated because it changes location. But this doesn't know that. This script doesn't know, or this function here, or whatever's going on here doesn't know that. And that's when we end up with invalid memory. Okay, good. But you always get, like, you get it so stumped when you get into those issues because you're seeing like, hey, what, this doesn't make any sense at all. And then it's like there's alarm bells ringing that, okay, there's something with the memory. And yeah, now it all works. Now we get all these error reportings. So if I restart, I go to type checker test. And there you go. Now we get all these errors here. Why do I see them though? I don't want to see them. I guess it's for demonstration purposes, it's fine. Okay, but here's kind of weird. It says that it wasn't found, which is weird because it is there. And I would like to check now. Do we also get, so you can see, no, we only get errors in this file. But if we open up module RN, there is an error here that we didn't get. I guess maybe that's because the LSP didn't open that file yet. Identifier S not declared. Yeah, that's only in this file. Okay, cool. But now we get these errors. Awesome. Identifier not declared. Yeah. And here, like, you get a type error, expected array of bytes, actual int. Cool. But this is kind of weird. It says that it's not found. Why are we not finding this module? Because if I like go to the file, it's right here. Even Vim knows it's there. Yes, this is part of the LSP here that you're seeing here. This is the LSP pushing diagnostics to the to NeoVim. So the LSP basically runs the type checker every time the document changes. The parser and the type checker, and then it reports the diagnostics, and we get all the things in this here. So cool. Let's check why this is happening. We'll do type check only. God damn it, what is happening here? Type check only, log please, we get all these errors. And we got module not found somewhere. So the path is the absolute path. This is not found. Yes, that's not found, but that shouldn't be like reported as an error. It does find it, so it's not like it's not found. Okay, let's check if we actually report that as an error. Module not found. Like this one doesn't report the error, it just returns the error. This one gets error not found. If there was something wrong with this one, it reports module not. Okay, so wait, how does that work? So something went wrong from that part, it returns module not found. It should just return. Oh, I see. If we got document not found, it returns module not found.
So apparently the document wasn't found. I'll just log error here. Document not found. Oops. I mean, it's like we get a module not found, but then it doesn't really report it as an error. Let's see this other thing here, this one. This might report some weird things. Member identifier module, run identifier. Well, that seems to actually not report anything. Assignment error. We got a span error. Okay, whenever we report an error, I should just I should also say what the error was. Error, and then the actual error message. Wait, we don't have the message. Well, we could do like plus format. No, but then we need to. Let's do. No. Let's do this. And I will log without prefix. Format args. Yeah, catch. There we go. So that's the message that we get. No, that's just for error. If this is an error. No, this should be out here. What am I doing? There we go. Yeah. And we can even do like error message. There we go. Of course, we need to add a new line. All right, identifier C not declared, makes sense. And then we get all the compilation. Identifier A not declared, identifier Y not declared, identifier name not declared. Oh, the assignment error didn't have the thing, so let's add that there. Now we can try because we're not in an error defer. And let's also do the expression error as well. Actually, is this even called now? No. I'll just remove that. Format. Oh, right. We don't have that. Well, I guess we don't need this since we always do the span error. Okay, okay. Fine. Read for S not declared. Wait. Okay. So this never generated an error, and this... So why do we see the error? Was it just a caching issue or something? I'll just do this. Type checker... No. No, it says not found. Where is it? Oh, maybe it's from the LSP. You use WSL, I think. Yes, I do. Okay, maybe it's from the LSP actually. No, it is. Oh wait, I see. Okay, there could be something wrong with the LSP document store. I see. Right. Where is the... Where are the interface symbols? Oh, interface implementation. So, yeah. Okay. So basically here, when you're working with the LSP, we're working with like... I see what's going on. So basically, when we load the file in the LSP, we don't really read, we don't open files ourselves and read them. We get the contents from the client. Yeah, it's the LSP document store that it doesn't open and read the file. We get the file, we get the text from like the LSP client. So I'm not sure if the server can like request a file or something like that. If you don't request them, you can request some. Yeah, I'll have to check it out here. Where is the thing? Did I close the LSP documentation? No, here we go. All right, here's the specification. Sorry about the brightness, by the way. Thank you, Toto, by the way. All right, document synchronization. Will save. There's so many of these that we don't really handle as well. So there could be other issues.
for documents actually saved. Okay, I guess we don't really care about this. Did save, did close, did open, change, rename, overview, notebook, document. Notebooks are becoming more popular. Adding support. I don't know what notebook is. It seems to be a whole thing. Adding support. Notebook editors. Collection of. Okay, I don't care about this. No. Workspace. Will create files sent from the client to the server for files are created. Document link resolve. Sent from the client to server to resolve target of a given document link. Well, that's not exactly what we need. Document color. Okay. Document linked. Sent from the client to the server to request location of links. Ah. I mean, that could be something that we actually want to have, like, because there's a it's basically the import is a link, you could say, like it's a link to the module file. So I'll write this down here in the to-do. Add support for document links, question mark. Call hierarchy. Request from the server. So incoming calls for given call hierarchy item. You would think it's probably somewhere in here. Open change notification mandatory. The protocol clients cannot opt out supporting them. This includes both full incremental synchronization, which we have. In addition, the server must implement all three of them or none. Okay. I think I'm not sure what we do with did close. Maybe we don't really care about that one. The capabilities are therefore controlled via a combined client and server capability. Opting out of the document synchronization makes only sense if documents are shown by a client or read only. Otherwise, the server might receive requests for documents for which the content is managed in the client. They might have changed, yeah. I mean, I guess maybe we could we're keeping track of all the documents that are opened, and if it's not open, we open it ourselves or something like that. But we're not. I don't think we're supposed to do that. Like, it feels like the correct thing would be to kind of send a request to the client to request a document instead of the other way around. Or yeah. Dynamic registration controls whether the text synchronization supports dynamic registration. Only covers the property specific to open, change, and close notification. Complete definition is there. Okay. Yeah, but we have incremental, so that's fine. Did open. Newly open text documents. Sent from client to server. Content is now managed by this client. The server must not try to read the document's content using documents URI. Okay, so maybe we can do that. I mean, this implies that we can actually read on the server, but those documents that are not opened yet. Open in this sense means it's managed by the client. It does not necessarily mean its content is presented in an editor. An open notification must not be sent more than once without a corresponding closed notification sent before. This means open and closed notification must be balanced, and the max open count for a particular text document is 1. Right. Note that a server's ability to fulfill requests is independent of whether the text document is open or closed. Did open text document pairs contain language any? Okay, so what I'm reading here is basically we can read files. We don't send a request to the client. We just read it if it's not already opened by the client. So if the client has did open, we now turn on the flag managed by client or whatever. And when it say did close, we turn off the flag. And if it's not managed by the client, and we didn't open it before, we have to open it again. Okay. Okay. So it's a little bit more thingy majigger here. Open. So this is like, this has to be from the client then. So we open or replace, and the document itself needs to be like managed by client. I guess no, let's force it here. So this case, it's managed by the client, I guess. Okay, let's make this into like an enum instead. Let's do like, I don't know, mode. Client server. Let's call this like managed mode. Oops. Client. Okay. Okay, so it's managed by the client. I guess we need one version that is, we open it server on the server. Do we have something like request documents or something? No. Also, we can kind of assume, like, as long as it's not opened by the editor, we can kind of assume that the files haven't changed. I don't want to have to like read open the file every time. We could, but okay, so we have URI, we should have path. URI is kind of the same thing. Text is like, no, we don't have text. This is like server open or actually request document, and we get, wait, I mean we have get document, I guess, but we don't really, we have get document, but we don't have like open, like requesting it to be opened and then returned. So let's have it this here. Version, we don't have a version. No. We would get a pointer. What is going on over here? Fetch, remove. Oh, because of the replace. So we can try to get the document. Yeah, ask ahead, Blue. Okay. We have the key. We create a new document. Version, I guess, will be 0 or null, maybe even. Like if it's managed by the server, we don't really have a version. Maybe the version, maybe that should be a part of managed mode actually. Because once they close, I don't think the version matters anymore. We could just say 0, fine. Because when we send diagnostics, I think you have to send a version as well. Yeah. All right, but then this would be the server. And then when we put a function inside a zig struct, does it change its natural alignment? No, I think the function is basically stored somewhere, you know, in like a function. I mean, it's stored, it has an address. It's not really in the struct. The function, I don't think the functions affect the struct at all. Unless you have a pointer to a function, then that's different. But just declaring, or is that what you're talking about? Like, because like it's like anything that is a field will affect the size, will maybe potentially affect the size of a struct, because there are like 0. Okay. So basically here, let's have a struct, my struct. Okay, now this, at this point, the struct has 0. if the size is 0. Because it doesn't have any fields. This one, we add my field u32. This would be 32 bits. Or what is it, 4 bytes? Oh, whatever. My struct 3. Let's have a, God damn it. No. Let's add a function. My function. And we can even log, you know, hello. The size of this is still 0 because there's no fields in it. This function gets stored as like a global address. So you can refer to this function from anywhere in the program. It's not stored in the struct itself. It's stored like outside somewhere. But Zig knows how to, like, you know, connect the thing. Even if you have, like, you know, like all functions are basically static things that are stored in some probably like read-only executable memory somewhere in the program. So if you have like reference to this, now this is a member function, but it's basically the same thing because it's just a function. Yeah. So the struct have its address stored or not? Not in the actual struct, like runtime data. It's like, okay, if you have something else, like let's say you have my struct 4 that has a field called my struct 3, which is a my struct 3. That's the struct with that's this struct here with the function. And then you say you have another function here, it's like my other function calling my function. So we have self my struct 4, and then we like void. Now you can say self my struct 3 and call my function. Okay, not sure why it wanted me to put something in there, but this, when you call this, it's not like you're accessing the data on my struct 3 to get to my function. What's happening is that actually you just call my function on the type of my struct 3, and then you supply this as an argument into the function. So the function itself is not stored in the struct, it just kind of looks like it. What happens when we don't use pub inside a struct? So pub means it's visible or accessible from outside this file. So if you notice here, like this is pub. Okay, I don't need this to be pub actually here, because we're in the same file, so I can still access this function from here. But if I moved my struct 4 to another file, and then I like import my struct 3 and try to use it here, use a private, like a non-public function here, then that would be like an error there. So, but it's like other functions or other structs that are inside the same file, they can access these kind of quote-unquote private files. Yeah. And by the way, the size of this is also 0. Yeah. Because the size of my struct 3, even though we have a field here, is 0. So the size of a struct is just the sum of the sizes of its fields. It's that simple. And then you have alignment as well, but you can kind of sum it up like that. But then I think zero size structs are treated like a little bit differently because they have zero size, so they don't need to be stored anywhere. All right. So we're creating this document. We should also now open the file and read it. So let's do that. So the path should be like a absolute path that we can do. So let's create. Let's get the file. Actually, standard working directory. No wait. Well, okay. Let's just keep it like. When you're opening a file, it's nice to use standard like the current working directory. Unless you want to make sure it's an absolute path, then you can use open file path absolute, and that will kind of assert that it's an absolute path. So if this is not an absolute path, this has become an error here. But if you want to allow both absolute and relative, then you can use current working directory open file instead. So this would accept both relative or absolute paths. So I'm gonna use that for this. Yeah, we don't need any special modes. So we'll try to open the file. If there's if there's an error opening the file, we should probably handle that, but I don't care right now. Because basically the LSP will kind of crash now if this happens, I guess. Unless we handle the error in here, but I guess any step of the way here will crash the server, I guess. But yeah. So that's the file, and then for defer, we need to close the file. I need to check, do you need to be mutable? No. Alright, now we can create the file reader, which will be file.reader, and we need a buffer as well, so I'm gonna say file buffer here, and we need to create the file buffer, and I'm just gonna store it as a small buffer there. And then you are a reader, and then we get the actual reader from file reader.interface. Whoops. Now we have the usual like reader interface, and now we can say. I mean, you could also, there's like a read all or read, you can also use this. I'm not sure if this is supposed to be deprecated. Yeah, this is supposed to be deprecated in favor of reader. So you're supposed to do this here, which is fine. You could use, I have a library for this that I made, I think. Wait, oh, I don't have it here. Okay, never mind. Now we will read the contents. So this would be like read. Actually, you know what? Let's do this even more fancy. Let's create a writer as well. So I will create a writer. And this would be writer and then allocating. So we'll create an allocating writer with some kind of allocator. Do we have that? Self allocator. There we go. All right. This is the allocating writer. And then we create the rider. It's going to be allocating rider.rider. There we go. Now we have the rider, and now we can do reader stream into rider and unlimited. So now we're streaming in from the reader into the rider, and we're basically reading the whole thing. Okay, and we do a try on that one, of course. And then this returns how much you wrote, but I'm gonna just ignore that. And that will now store the text with the allocator. Now we should just, yeah, we're just putting that in there. Okay, so we are duplicating the text, so we should actually have to take care of this. So I'm gonna just initialize that. Right, so that should free up the allocated, the red text there. It's kind of unnecessary that we're duplicating it here, but whatever. It feels like hidden witchcraft because in C you put pointer to a function, which makes sense. Yes, I mean you can do that here. You can actually that's how like the interfaces work. You can have a function pointer is request document, for example. Although here it's like way easier because you can just do that. But you can have and you can see the type here. It's a function. And then, but then you can also you can have the type is gonna be a constant pointer to a function, and in this case I'll just copy this signature here. Okay, so now this is a pointer to the function. I have to namespace that, right? And then I can put that there as well. Okay, it has an infer. Okay, there's a little bit with the error sets you cannot infer now, but you can basically define a you know, a pointer function like this. Now this would be like this specific signature. If you just do this, it will like infer the signature. But this potentially now, if you have this as a field, you can actually change the pointer if you have like a common function type that you want to switch out. In like a V table, for example, then you can actually store different functions on this, you know, depending on what you need. But I mean, in C, it's like the same thing. Like it stores functions as pointers. You know, every function needs to be somewhere. It needs to be in the program somewhere, and it has an address. Like every function has an address, and in order to actually call a function in like assembly, you have to, you know, you have to call the function. You have to know its address to know where to go. So it works exactly like C. It's just the syntax is different. I'm pretty sure. Like filer buffer. Okay. So it's kind of a long thing here just to read a file. But basically, we open the file, we close it when we're done. We have a file. We have a little buffer here, which we use to read in a little bit at a time. We create a reader. We grab the interface. So that's the reader part, and here's the writer part. We create an allocating writer, so we don't have to worry about any buffers or anything. We deinitialize it at the end, so this buffer gets like returned or deinitialized or freed up. And then we grab the writer interface from that. I am annoyed that it's not called interface. It's not the same name, but they do point to the same kind of thing. Except this is the reader version and this is the writer version. And then we just call the reader stream, from which I recently enjoyed using in the pipelines, when the pipelines needed to stand it out into something, standard in or something. Then you can use this streaming thing. So this streams. However, we're not done, I don't think, because this will just stream whatever is available currently. So yeah. Also, I forgot, the writer needs to be flushed as well, which is not happening in here. So we actually need to flush the so basically here you need to you need to do like while true, and we get bytes read here. Maybe this was way more complicated than I thought actually. And then it's like byte read is more than 0. We do writer flush. No, we don't do writer flush actually. No, we don't. Okay. Because we're not writing to stand it out to something. We're just writing to this buffer here. And to get the text, actually you do buffered there. Okay, that's the text. But we should stream until it's closed. So let's catch an error and we'll switch on the error. And if we have like stream ended or something, what is it called? End of stream, right? So if we have end of stream, we can break. If we have something else, we actually return this error. Then something bad happened. Okay, so now we're reading until we have the end of the stream. Cool. Which is really convoluted. Actually, you know, you can also do like reader and then like read slice all, and then you provide a buffer that should have like the maximum you know, allowed whatever. You can also do like read alloc and then have a maximum length that will read everything basically. I don't know, I just wanted to show this here. But this allows you to kind of stream in the content instead of reading everything at once as well, like if you want to do something else in the meantime. All right. Or in the other case where I have like standard in, standard out, standard error, I actually stream both of them at the same time. So then you kind of have to do this kind of thing basically. Okay, and then we get this the writer buffered, and then the document gets the initial on error, right? This gets initialized always, this gets closed, this gets freed on error. Right, everything we want to keep, we do defer. Anything we don't want to keep, we do defer, basically. And then we have the entry, and we populate it with the document. We run the analysis on them as well. Okay. So this should be good for opening a document. If we already kind of have the document, we have stored it in the map, so we can just return it directly. Now, I just have to think about the different scenarios here. So basically, let's say the server opens a file, it sends did open. Now it's going to use this function instead, which provides the document text for us. So we just populate the document with that text instead of opening and reading it. But then let's say the thing says like did close. Now in the LSP server, we don't actually handle that, I don't think. Okay, we do, actually. We actually remove it. We shouldn't do that. Yeah, so I'm gonna comment this out. So this is gonna be handled a bit differently right now. What we're gonna do is we're gonna get the document. Get. No, wait. Self get. You're right. So it's not try, it's like this. If we didn't get it, then we don't really need to do anything. It's kind of weird. We should have it if we get a close, but if we didn't get it, then it's fine. And now what we do instead, we say that the manage mode is going to be equal to server now. And I think I also want to set the version to 0. Maybe? I don't know, actually. Like, I'm not sure what the version handle process is for server managed documents, but I guess we'll find out. Okay, so that's, I guess, all we need to do for closing a document. We just say, hey, okay, now we are managing it, and we set the version to 0. Okay, what else do we need to do? So update should only happen on things we already have, like managed by client. Open or replace could happen on a thing that we have already that is managed by us, but in that case we just remove it here. It just gets removed and deinitialized. So, and then replaced by this. Yeah. But if we get an let's say we get an update for the document that is server managed, that doesn't make sense. That shouldn't happen. If the manage mode is server, we change it to client. And I guess that's all we need to do. The rest will be updated anyway. The version, where's the version happening? Yeah, document. Yeah, so it's like updating there. I guess we just set this to client always, just so we have the correct state of everything. Because we're never gonna get the update if the server is managing it. The only thing that can happen is that someone calls request document, in which case if we have it we return it, if we don't have it we open it and read it, and there we go. Okay, now we need to call this from wait, right, so we just hook this into the get document, I think. Yeah, I think we just do this, because the get document can come from, yeah, that can come from like the type checker and or the parser or something. So if we need to open other documents, we will do it from here. And then this is gonna handle like the management. So yeah, so it's actually kind of not really that difficult. And the workspace, do we have the workspace? Oh no, the workspace, what are we using the workspace for actually? Describe path, rebuild symbols, report type checker. Do we even need this? Because we're kind of already doing these things, I think. So like what's happening is we call the type checker, which internal, like the type check here, which internally would request a document. But the only thing it's interested in is basically the source or the AST. And then it should have a bunch of diagnostics that we append. So the workspace is actually not really... Well, okay, we got the document store to create the thing. But we don't really need to call this a bunch of times. We just need to call this one time on the main document, like on the document that we're actually in. That's also interesting. Like if you call this, let's say you would call this on... Hang on. The diagnostics. Because the type checker could report diagnostics on other files. Yeah, this is the URI. So we get the URI from what? It should be part of diagnostics actually. It shouldn't just be self URI. No. This doesn't make sense. It has to be span start file, and then we make a URI from that. Solve URI, resolve, no. Resolve URI. Where is this? It's on the document store. So workspace, document store. Solve URI. And that's the path. Guess this would be a freshly allocated thing. And that's the URI. Okay, so now we can potentially, we can, you know, we run the type checker once on the file. But what I was thinking about is like, let's say you open the main file, and the main file imports another file, but there's an error in the main file that kind of depends on the imported file. And then you go into the imported file and fix that issue. Then the type checker only runs for the module file, the imported file. So the error in the other file is still there until we like save or change something. So we should actually rerun the type checker. Like we should run the type checker on the main file. Well, we can't know what the main file is. Whatever, it just has to be like that until we fix it, I guess. But okay, so now we get the actual file of the diagnostic, and we don't like force it to be this, because we could potentially get other files in here reported. Okay, so when we do, let's see, request, we actually don't want to run these things. Maybe that could be like an option here. Request document options. Because what's nice about this is we don't need the workspace if we do that, if we do it like this. So let's do request document options. This is a union enum, my favorite type in Zig, and let's do like open only, or yeah, open and store only, and then this would be like parse and type check, which needs a workspace to be able to do that. So we pass, so then we supply it. We don't actually need to supply it every time. We just supply it if we need to. So then we can say here, we can say switch on options, and if we store, wait, what was it called? Open, we don't do anything. Otherwise we have, what was it, parse and check. We get the workspace, and now we can do this, and there we go. Now we don't always need to put the thing there, so here we can say open and store only, and there we go. And you can be an error, so what kind of error can you be? I guess we have a bunch of different, we have like allocator error, open file error, reader error, stream error. Not sure what this would be. Allocator probably. Yeah, a bunch of allocation errors and these things as well. So a lot of different errors. Now, but this one only supports like the document errors, document store errors, which is like either we didn't find it or something else failed. So I'm just gonna I'm just gonna say this if we didn't, if it failed. If the file system, okay, let's do this actually. If we catch here and switch, and we get like file not found, then we return document store error, document not found. Otherwise, return error. No, diagnostic UI, let's say. Okay, so we request the document. If we catch this, if we get document store error, document not found, we return that. Otherwise, we will return get failed. What? Wait, why does path? Why is that not constant? Try. Ah, I see. It's not a try. There we go. Expected error unit found use size. Oh. We have a catch, so we remove the try. For some reason, it wants path to be mutable. I don't understand why. Let's not have that. Why is path mutable? Is it so we can edit in place? It doesn't make sense to me. Implicitly function with null void implicitly returns. Okay, so there's somewhere here we don't return. Alright, so we need to return over here. Return entry. Wait, hang on. Are you a pointer? No, you're not. Okay, let's see here. We have the same issue here. when we do this, there's a potential that all other documents are invalidated. So we should store them also as pointers here and not as a thing. Although this is a string hash map, so it's like slightly different, but I'm not sure actually how this works. I'm not sure if things can get invalidated, to be honest. No orders guaranteed. Any modification invalidates live iterators. Iterating. Okay, whatever. Let's just store it as pointers. And now we need to create the document with create document. And we do this. We also destroy it if there's something wrong. And then we get the container where it should be at, and we put it there. Yeah. All right. And then here we could just return the document because now it's a stable pointer, so we don't need to worry about that. Great. What are you saying? Well, we could just say document now. We don't need to worry about the value pointer. Okay. Now here we can just say get instead. Oh. So, okay. Kind of like, I was thinking like, okay, well, then I should just return the error because the error is document not found. But unlike TypeScript, Zig doesn't have like type reducing. So we have to do that. And that's fine. You are, wait, why are you, oh, we haven't done it here. So we have to do it here as well. Self-allocator create document. Maybe that's been the source of some of the weird issues as well. Some of the random crashes and stuff. So we populate it. Where does the text come from? Text comes from that side, okay. And then we defer. Now we need to allocator, self-allocator destroy document. We get the entry, or we store the thing there, and now here we can say document instead. All right. Update. I mean, I should just use get since we have it. Okay. Group documents diagnostics. Okay, yeah. Iterator. We get the doc entry value pointer. Should send diagnostics. Does it dereference? No. Let's do like document equals doc entry value pointer. Now we should be able to just say document, right? No? Wait, this is different. Get or put. Okay, we're going through all the documents. We're checking if we should send. We get the documents. We get the URI. I think the URI should always be... No, that's grouping. Okay, so we're kind of trying to group them together. Okay, I see. And then this is the groups. Okay, that's the group. I see. But that would have been some kind of type error anyways. No field or memory function, name, clear diagnosis, document. Okay, so same thing. Well, let's just do that. Well, there's a lot of these. Okay, so that was that. We should do the same thing actually in the front end document store as well. This has also a map. Oh, they are already pointers. Okay, jolly good. So hopefully now, if we open, we won't get this error. Actually, we don't get any errors. That was an hour ago. No errors. Crash. What? With no output? I crashed on like exit. Wait, so if we say LSP stop, it exited. Oh, here we go. Now we get something here. Okay. Flush the reader. Hang on, I'm just gonna check this. Man, that's a day. I got a major deja vu there. Wonder why. Yo, Penguin. Yo, SQF. What is that thing? Oh, that's the. Oh, that's the. That's the Kottefolket emoji. Okay. Where is the error? Like this log is so horrible to read. Invalid free. Yeah. We're cooking something. I don't know what. Okay, where is this invalid free? At Bucket Canary. What?
panic, invalid free. Oh, the allocator. Okay. Self path. Well, okay, we should dupe it then. And then we go to here, and the path that we send in comes from outside. Why is it mutable? What are you? The path comes from here. That should, so this path should be taken care of. I'm not sure about this path though. This path is probably not taken care of. This path is resolved here, and then we should refer free it now. There we go. Okay, so if we do stop, okay, good. Now we don't get the error, but we also don't report any errors. So not sure what's going on there. Error path. Received message, did open type checker, right? And then we got like this error message path here. From where? This one. Oh, yeah, module not found. I will do that. Remove it. There we go. Okay, so here we can see we got did open, right? Blah 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 blah. We will, and then we send like 0. So when it opened, handle did open, we send it to open or replace, which does a bunch of stuff. And yeah, we report the type checker. Wait, oh, I was like, why is this text white here? Maybe I put like LSP stop here or something. Okay, yeah. So this should run the type checker. I mean, I guess we could enable logging, but that's gonna be a lot of logging. Let's try and run this on here.
Okay, here we get some diagnostics. So as long as the path checks out, we should be good. Let's add an error log here. Type check path and see what's gonna happen there. There's a... No, that's not an... Okay, hang on. Oops. Okay. Yeah. It seems correct. But then nothing happens. So it goes in there and does its thing. And then we call this on the path. You will call something somewhere. Yeah, this one. Get AST. But then they should return document not parsed. If this doesn't, if it's not found here. Or, okay, so if there was an error, we catch it and it failed to, so we should get this failed to run. Error, document not found. Well, that is like way before. No, that's not happening. Okay. So this doesn't happen, presumably. I was thinking, like, of course it might not get this because we didn't parse the document, because we opened it from the other things, which did not, it just got the source. We never parsed it. And it makes sense that we wouldn't get the AST. So let's just see if we can try to make, like, we want to try to call this function. But we don't have workspace, that's the issue. We do not have workspace. It should be solvable though. So request document, when we call this, we don't really have the workspace unless we store the workspace in here. Actually, what do we need from the workspace here? You need the detail and the document store. Well, we have the document store. What about the detail? You know what? Let's remove this dependency and only use document store here. Okay. Actually, you know what? This is the document store, so we can just do like self document store. And what about this? This is also self document store. Okay, so the only thing we need is like describe path. I feel like we should be able to just... Why do we need like self here? Root items. What is this? The root like directories or something? Or... This is like... Yeah, this is like AI. I guess it's trying to find like which root are we talking about, and then create a relative from that root or something like that, and then that is used in like when we display the thing. But really this okay, maybe potentially you can have like several documents open at the same time in different folders or something. I don't know, I was kind of thinking it should just be like current working directory or something. Okay. Okay, another fix would be to just store the workspace here. Let's just store a pointer to the workspace. There we go. Fix the issue. Now we can access it. No, let's do undefined. Documents equals init workspace is self workspace, and workspace documents is self documents. There we go. It's kind of like we have two init functions. This is just setting up like the initial thing, and then we need this because we need to talk about where is the server, pointer at. Which is the usual issue in like the init functions. You don't have that. Okay. Unless you create pointers in the init functions or something like that. But now we should have the workspace has the document store. The document store has the workspace. And when we get this, we actually want to parse this as well. But we don't want to type check. Open and parse. Okay, now they both require the thing. here's the thing. There, so open and parse. No. Open and parse. Why doesn't it work? Oh, we don't need this. There we go. So open and parse only. This needs a workspace, so this would be like context workspace. There we go. Okay. Cool. And here now we actually do have the workspace, and we can do that. Actually, we don't even need to pass the workspace because we have it. No, self. Oops. And basically here we can do like if options equals open and parse only. We do this. You can have like convenience functions here, like should rebuild symbols. Self request button options. That should be true. Yes, that should always be true. And then should type check. Even though we don't really have need for this, but I just like to mess with different patterns and stuff. So this would be like if self equals parse and type. Actually, it's better to have a switch if in case you added more things. This would be false and this would be true. Very nice. I just love the ways you could do like options parameters in Zig. Very descriptive and easy to use. You are not needed, but we want to have you there anyway. This. So now instead of doing this, we will have like if options should rebuild symbols, we rebuild the symbols. If options should type check, we do the type check. Okay. Self workspace, there we go. And we can also, I mean, really, a lot of the things in open or replace or this is the same. So we could probably put that in its own thing, like process document or something. And then options. We could rename you to like process document options. And then we basically do this. If options, blah, blah, blah. Yeah, we don't need you. We're gonna have options. And then down here we're gonna say, whoop. We're gonna say try process documents with the options. And then over here we'll do the same. Alright. And I guess this would also be a thing. Like this part is just reading the file. So I want to move this. Read document file. Path. No, we don't get a document. We get a string. Alright, and then we return writer buffered, but we do not. No, actually, now you can do like to own slice, I think. To own, wait. I thought you could do, oh no, it's alloc writer to own. There we go. So we will return that, which makes it so that we don't really need to deinitialize, but it's good to have this anyway because there could be an error, and then we need to, and then we probably want to deinitialize anyway. And of course, it can be an error. All right, so now we can say here, we can say contents is gonna be try read document file path, and there we go. Now we got the contents, and since the contents are like duplicated in here, I'm just gonna free it here as well. And now it should be contents instead. Okay, so a little bit more manageable here. We can basically see a lot of similarities happening in here as well. So that was, I was trying to think about, okay, we should probably just move this into its own thing, which is like, I don't know, set document, assuming it doesn't already exist or something like that. Well, actually, yeah, we create a document and we store it. Yeah. Okay, let's just do like set document. Just to make these functions look a little bit nicer. It's like, there's so much weird stuff going on. We need the URI. We need, I guess, yeah, with the path. We need the text and the version. No, where's the version here? Types. And then we don't need anything else, I don't think. Okay, and this should return a document. Actually, let's do like create and store document. Something like this. Return the document. URI path text version. There we go. Create and store document, and then we process it. We actually get the document out. Awesome. And let's do the same thing down here. I'm just gonna do this and double check that it's basically the same thing. So we got like key is URI blah blah blah. We're instead of, yeah, this is how we get the content, so that's not in here. And here we create a document. We do, all right, the client server, right? Okay, very important distinction here now. So let's add the managed mode, document managed mode, and then that should be put in here. And there we go. Entry is the same, we put it there. Okay, there we go. But now you need to be the server manage. Text is actually contents. Whoops, did I remove that? Well, I guess we can easily get it back now. Read document file self, of course, and the path. That's the contents, which we need to also destroy. There we go. Version is 0, right? That's right. Why do you not report an error? Ah, here. Open or replace. You need options. Now this should be parse and type check. Very good. Okay, is that it? We still don't get any diagnostics. Or do we, actually? Oh, we do. Hey, there we go. I think it's some like the LSP. Oh, we get the wrong line? No, this is the wrong line. Okay, well, identify S not declared. What is this? S not declared. Oh, you know what? That's probably from the other file. Oh my god, we get... Okay. Why are we... Why do we get all these now? Yeah, thank you, Todo. I saw it. Let's see... Because I disabled that we shouldn't like it had this when the AI made this thing first, it when it loaded like a workspace, it went recursively through all the files, but I disabled that. But for some reason now it's back. What the hell is happening here? Okay, whatever. Oh yeah, these are like the autocomplete for some of the stuff. Workspace. Refresh. scan route. Walk deer. See what it's doing here. It's like walking through the entire thing. And then it's like, where is the thing? Iterate. Like, we don't even need to do any of this. We like, this is so we don't need to do any of this. Like, what is it actually doing in here? We're opening a door, we're iterating, we're going through all the things, we're creating an absolute path, we're freeing it later, we're creating a relative path, we're freeing it later, we're looking at if it's directory, we will recurse, so we don't do anything. If it's a file and it ends with runic, we do index file. Okay, index file. Index file. I mean, I guess it could be nice to have an index file. I don't know. It feels unnecessary though. At this point. File, it opens the file, it reads the content. Okay, there you go. There's another function, but this is deprecated as well. So. And we have max source bytes if it's too large, like 4 megabytes right now. Free parser, it's parsing it, and it's also storing it in the document store as well. Okay. Or it's using the document store anyway. We parse the file. Yeah, but this parser is like different. This parser, it only lives in here. The parsers are supposed to live on the documents. So yeah, we have a parser on each document. It's not like this is kind of, this is, it's detached or something here. And then we call collect symbols, which will do a whole bunch of weird matching things. Yeah. This is not great. I think we just don't do this at all. Where is, yeah, index file, scan route, like this doesn't, we don't do this. Don't actually do this. There we go. All right. Okay, now we get these because they're like the LSP config is weird, or it's not initialized properly, I guess. If I go into Zig, does it disappear? Yes, it does. Okay, so it's like I have a specific config for Zig where I hide all the things. If we open this, we see everything here. Okay. Why do we get this though? I was thinking like, okay, this feels like it comes from another file. Which, if we open up module rn, is the case. This is actually an error from this file. I thought I tried to fix this. Okay, we do get, this file actually get the correct errors. But why do we get this here? LSP document. Is it something? Because this is what I was thinking here. Like we take the span of the actual error and the file, and then we use that as a URI. So I feel like it should know which URI we're talking about. But maybe something happens when we report it. Because it's not, I guess this is reporting from this document. But no, but this is like self-diagnostics. Maybe this should be like more, where, okay, so the diagnostics is found in this file, but the URI could point to some other file. Maybe that's the issue. Yeah, the diagnostics are leaking. So when we process, when we have like a thing called flush diagnostics, which will basically group up all diagnostics and send them out file by file. So basically we have a bunch of we have a groups where they are grouped by documents, and so the URI is the group, you know, key, and we send diagnostics. So what you do is you send for one file, you send a list of diagnostics here, and in the group thing, and then this is just a defer to cleanup. Wow, that's a lot of cleanup. And in the group thing here, it will go through each document, look if we should send diagnostics, which we basically always should, and then we get the diagnostics. We take the URI from the document URI. So this is where things go wrong, I'm pretty sure. I'm gonna take this from the diagnostics instead, which makes a lot more sense. Or wait. Hang on. Yeah, we just append this line. We should actually be looping through each diagnostic and like do this every time, and then we just append one, which is the. So it's a little bit less optimized, but whatever. I just realized instead of using like these weird groups, you could actually use whatever. I'm not gonna think about that right now. Let's see. Let's just fix this issue here. D diagnostic, right? So we have that. We need to get the entry in here and the URI as well, and then. I mean, okay, one thing we could do is we could report the error. We could still keep this thing, but here we could say that, okay, well, if this URI is something else, we need to request that document, because we should have it then, because we've gone through it, and report the diagnostic on that document instead. Yeah, let's do that instead. Okay, we don't need to change this. Yes. Okay. Even though each diagnostic has a URI, let's just make it so that they actually report or put in the document where they should be. So we have the URI, and then we do like diag doc is gonna be documents, and then we do like I guess if it's not no, we should actually, yeah, we should just use get. We should have it. We could use request. No, let's just do get URI. I'm gonna unwrap here. It has to be there. We just did type check on it. Okay, and then this will be doc. There we go. Diagnostics append. There we go. And if we open up the thing, we get the module RN. Even though we haven't opened it, we get it anyway. And then we can open it like this. Wow. Okay, basic LSP functionality. But yeah, that's awesome actually. I mean, yeah. Cool. All right, well that feels like a big chapter being closed. Or, I mean, a little bit anyway. Where did I put the thing? LSP. I don't know if this has worked or if I solved this or not. No idea. Let's do. What did we actually do? Like, well, we did like type checker and integration, and now it supports type checking imports. So type checking imports, I guess, is what we did. And okay, I don't need this thing. So we have imports. There we go. Cool. All right. Now, okay, one thing that doesn't really work though, that what I want to do is this as well. I'm not going to do it right now. I have to go now because yeah, I need to go. But this would be really cool. Like, what this will enable us to do is basically to get auto completion that is scope dependent. So you would be able to, because the you would stand in like here, and then if you want to like autocomplete, well, now we don't have that. Also, there's some bug in compare, I guess, but we try to get some kind of autocomplete. If we're in the scope, we should, you know, it should be context dependent. If we're here, for example, we should get Y. Out here we shouldn't get Y because Y is not declared here, but here Y is declared. And also this is kind of weird. There should be an error here saying that int cannot be assigned to string. Maybe are we skipping the blocks as well? I'm not sure. But anyway, that's what we want. So basically, that will enable us to, if we can say that to the type checker, hey, I'm here. What scope do I have? You know, what kind of variables or whatever? What scope what can I do here? And then the type checker would be able to report back, okay, you're in this scope. So basically, what we do is we send like a line, a column number, or whatever we get from the LSP client, and then like some sort of position, and then we have to be able to figure out, okay, which scope are we in, and just return that information to, I guess, the client. You would return, well, actually it would be something, it would be like a autocomplete. Yeah, I think it would be some kind of autocomplete request or something. Completion request. And yeah, the type checker would say, okay, we're in this scope, so you should have like Y or B or S or whatever, all of these things. So that would be very, very, very cool. But before we can do that, and I'm thinking like this here, where we do like we have the scopes, and I'm thinking like, okay, how can we like collision detect, so to speak, collision detect the scopes based on like line numbers and columns. That's basically just a 2D number, right? It's like a 2D, you know, it's like a 2D grid, so you should be able to like collision detect the scopes. But what I'm thinking is basically, to make it more like simple, we're gonna do some kind of sweeping algorithm on the on the lines. So basically we're just gonna say that, okay, well, the scopes are, well, you don't really need to do a sweeping algorithm either. You just need to have some sort, maybe even like some kind of binary tree or something. But here they will have like a length. So it's like a 1D. You could do like a 1D tree of some kind. Not a 2D, not like a quad tree, but like a 1D equivalent or something like that, where you could like, okay, well, we could very fast find which scope we're talking about. Maybe it's not needed because the line numbers basically are, you can very quickly, I guess, maybe find the scope. But yeah, this is the first time I'm doing this, so I'm just throwing out ideas here how to actually do this. But basically, you know, you can do a very naive version as well to see if it's like fast enough or whatever, where you would just go through each and just find the scopes that are where you are basically. But you would need to like return, I guess, the deepest scope of where you are. The deepest scope. You could potentially be, could you have several scopes in different branches at the same place? I don't think so. Yo Penguin. I'm basically finishing up here, but yeah, and before we can do that, we actually have to do this, because if there's like a parsing error, the whole system halts basically. If there's a parsing error, we can't actually continue to do the type checking. So we have to implement some kind of fix that will kind of read, like if the parser fails at some point, we want to read until like an expression terminator and then continue parsing from there, so that we can still have some kind of valid AST, which the type checker will then use to find errors and stuff. So you still get like, you know, you still get errors, and more importantly, or very important, that we can still do like a scope lookup, so we can see what we need, what we can actually do in the scope, even if we have a parse error. Which I feel is not how the current, like the Zig LSP works right now. The Zig LSP is very good, and it has a lot of nice features, but let's say I have a, like right now, let's say I have a switch here. I can't get, okay, well, script and that is the only thing. Okay, I do get this now. Okay, that's a bad example, but what if we had like, let's say we have like some kind of union enum. Usually this doesn't work. Like usually if you have a bunch of things in here, and then we have a function something, we take a UE, and then we switch on it, and you can see we don't get anything. Like we don't get auto-completion here. Oh, I see. Yeah, because you need to add this. Okay, well that's fine, you know. The parser could be lenient here and still, you know, we can see that, oh, we got a public thing here. Okay, well then that's a terminator, so we could automatically have this be correct. What about now? Okay, now we actually get it. Okay, I usually don't get this. I usually don't get these things, but now we do. Okay, great. I was gonna demonstrate when the LSP doesn't actually work, but let's say you do this and you're like, okay, well then I want to add the next one. No, I have to like complete this first, and then we get this next one. Except we don't always get it. It has to be like, well, if I go to the type checker actually, and we go down to some switch. Right, now here, let's say we remove these. We don't get anything. Like I don't get anything here. Even though self is, you know, it's data, As soon as I go down here, press dot, you can see all the syntax goes crazy, right? The syntax goes crazy. I don't get any completion. I don't even, I can't inspect here. So that's what I'm talking about. Like, yeah. All right, anyway, so that's what I wanna have in my language, is I wanna have like the parser should be able to kind of exit out from this failure state and still be able to parse through the rest of the stuff. So we get a bunch of, like, we get the AST. I guess in the case of this, it would probably, like, yeah, this is not correct, you know. But if, like, I would correct AST right now. But if you're here and then you're like, oh, you get this. Oh, but that's incorrect. Okay, well, let's treat this as a terminator and then continue here. Oh, we got a semicolon. Okay, we get this. Okay, we get this. Okay, we get this. So these are all terminators, basically. But then we get here. Okay, now we can start working again. But then it is kind of hard to know the scope, I guess. Where is the scope at? This is like an inner scope. Maybe that's the issue. Like, this is an inner scope. This is a scope. I guess you could try to say that right brace will get you out of the scope or something like that. I don't know. We'll see what we can do. But yeah, I'm not saying it's easy, but I'm saying I do want to try, and we'll see how far we'll get. My Python CPP LSP doesn't do this. Right. I had a feeling that this is always the case for me, 90% of the case, but you're just lucky. Yeah, I think maybe it has to do with how the scopes are. Like, let me try again. Maybe, I don't know if it's a file or if it's if you're in the outermost scope, if it's easier for it to figure it out. So we have this. It doesn't even have to be a union element, I think. And a switch. No. Well, you can actually do this. And a switch on that. Maybe we can do a comp time. Sure, why not? Okay. See? It works here. What if we have a function? Some more stuff happening. No, still works. Yeah, but that usually never works for me, as you say there, Toto. All right, yeah, but that's gonna be it for this time. So yeah, thank you very much for joining me today, and hope you have a nice day. And I'll see you later. Let's see. I guess we have a couple of people in here. We can raid something here. Let's see. Gleam. Are you interested in Gleam? I've never actually seen Gleam. Sure, let's do some Gleam. All right, see ya.